So good morning, everybody. To be on time, this is 9 o'clock Oman time. I'm starting, and today session is about sharing my experiences and knowledge in the area of turbine oil analysis as well as filtration with all of you. So I will kick off the meeting now, and then in 15 minutes the technical talk starts. People are coming in. Let me just activate all, and then we go ahead. Okay. Just explain about how I am going to do it today to be beneficial for all of us and to be also properly managed so everybody asks their questions and then communication also happens. Because it's my daily job, I am doing it every day. It's not about me talking, it's about you as well as if you have questions to talk. So, what I have arranged is that in the next 15 minutes, I will be just introducing myself and what I have done. And then around 1 hour, 15 minutes, I will be discussing on each and every test which is done on the turbine oils to have a clear understanding of how each test is done, what are the targets and what are the limits, because for each oil analysis test, it's our job, it's the industry people job to put the target and limits. There can be recommendations from OEM, from labs, from turbine oil manufacturers, but it's important that you as the user of that oil to put the targets and limits for each test, and then because you know the maintenance you are doing on that machine and you know the issues. So the targets and limits to be defined for each test after this 1 hour, 15 minutes. And then I think the beautiful part of this today happens after the coffee break that we put it. In these coffee breaks, I open up the voice and then I read the chats and as I read the WhatsApp groups. If I can answer half an hour the questions, I will be answering the questions on oil analysis when I am doing this coffee break. So for me, it's not a coffee break, but you can have your own coffee. So question and answer of the first 1 hour, 1 hour, 15 minutes will be done in the first coffee break. Then what I feel is the beauty of today is 1.5 hour of oil analysis tests, which are from my area. I have removed some of the lab data, lab names, but data is real from my region, which we will be analyzing together with our end user turbine oil analysis reports, which I will be diagnosing in front of you. And then the next after this 1.5 hour of discussion on oil analysis reports, which is a uh, practical part of it to put the knowledge gain in the first 1 hour, put it into practice to see some oil analysis reports from the real world. And then we go for a 1 hour break. In this break, I am available. I talk to my family that today no lunch for me, so I will be talking to you again, opening up the microphones, and then if any question is there, I will try to answer it. And then 1:30, I start with different filtration technologies because there are 3, 4 technologies today applied to non-turbine oils, which we need to understand the difference and then which one has I mean, any of them has a positive and negative. We should know the complete comparison of different technologies. And then after this filtration part, short break. If not needed, then we can pass this break, I think. Then we go for different filtration technologies and the comparison with EPT that I am working in, and then at the end the question and answer. So this is the my whole day that I am going to spend with you. If you would like to know more about each other, I really appreciate that you really use the chat function in Teams. I will check the Teams chat as well as the WhatsApp group, so you can discuss with each other or ask questions from me. So let us make it an interactive day together, so it will be beneficial for everybody. So let me just see. Normally in these online meetings that I do, end of the meeting, many people they will leave and they will not come in, or they will be just in the middle, they go out. If you can turn on your camera, I know if you're in a position to turn on your camera, turn on your camera. We take a group photo just as a memory of today that we are spending time together. I take this photo, then I kick off today's session. I don't know if you can uh, turn on your camera, but let's see how many will turn on. Martins, Chandra, thank you. Ali is on working. Ali is in the field. Very good. So yeah, Muhammad Wasim, thank you, Vitor. I think Vitor is late night in Brazil, I believe. Yeah, yeah, yeah. So thank you very much for joining this photo. I took it, I put it in the group just as a memory of us together. We do some knowledge sharing today. I think there is a page two as well. Nobody in page two. There is Francis there. Wow. Solomon is there. Ravi is there. Very good, very good. Alhamdulillah. I'm so happy of having all of you. So hoping it will be a valuable day for all of us. So thank you very much for the photos. You can turn off your camera and relax now. So yeah, I will just share my slides and then go ahead. Bismillah. So EPT Clean Oil started in 1992 by a Turbomachinery manager, Peter Dufresne Sr. He was working with TransCanada, TC Energy, the heart of oil and gas in Canada, as well Alberta in Calgary. He was managing 100 turbo compressors, and then he was a mechanical manager of these facilities. And then he had three, four turbines having unplanned shutdowns during the year due to lubricant deposit, they were calling it that time. And lubricant deposit was something like a sticky, brownish, golden color sitting on the bearing surfaces, servo valve spools, tanks, and filter elements. And then the existing filtration technologies, which were deep filtration methods like mechanical filters, electrostatic filters, cellulose-based filters, they were not able to capture this material. They were passing the filters and sitting on surfaces. So he invited the chemists around him to investigate, and then understood that the lubricant failure, the first and the top most important reason for lubricant failure, is chemistry related, is the oxidation. The base oil molecules are reacting with the air, and they are breaking down. The hydrocarbon broken down, failure of that one causes a free carbon, or we call it free radical, formed, and that free radical can again react with oxygen around it and then cause acid and then alcohol and all the oxidation byproducts to form. So then he understood that the first form of this breakdown product in the oil is dissolved. It is soluble. It is inside, and then it comes out as a solid. It sits on the surfaces. So metal surfaces are absorbing it, like sticking to those metal surfaces. Once he was analyzing the case, he was understanding that the turbine oils, mineral oils, are non-polar, and then the lubricant failure molecules are polar. And we need to learn a little bit of chemistry here as well. So chemistry, I mean, like polarity point of view, magnets, how they're attracted to each other. The molecules of lubricants also have a positive charge and negative charge, and then the fluid can be also polar and non-polar. In chemistry, the fluids which are non-polar, they dissolve in non-polar, and then polar dissolves in polar. So he understood that the non-polar lubricant is generating a polar molecule which cannot dissolve in the same turbine oil. It is staying sometime inside, but it is coming out as a solid because it is saturated, it cannot hold it anymore, and the metals are polar, they are attracting the polar media, which is the varnish inside the oil. So he understood that the technique that he needs to use it, he needs to remove the soluble varnish, and then he patented for the first time resin-based filtration for lubricants. So the resins were applied when he did it for the first time, 1993, in his own company. The resins started removing acid, as well as all other polar media. So it was a sacrificial polar media. So those varnish will not find the path to go through the surfaces. It will be attracted to the resin, which is a reaction called ion exchange. So the molecular form of filtration started with him, and then he got very good results in his own company. He cleaned the oil, and oil started collecting back all the varnish, and then he got the award, and he has started his own business. He started getting calls from Ministry of Defense in America, first, and then EPT Clean Oil started. So very nice journey of 30 years of EPT Clean Oil, more than 30 years now. And I have been part of this journey from 2014 so far, which I will be explaining. We are part of the ASTM Turbine Oil Committee. I want to discuss about this ASTM Turbine Oil Committee, which I have analyzed it. Anything comes out of ASTM Turbine Oil Committee, there are turbine manufacturers like GE, Siemens, Mitsubishi, and others. So they are turbine experts. Then there are filtration experts, global companies I'm talking about. Then there are oil analysis laboratories. There are oil suppliers as well. So anything coming out of ASTM, it is consensus basis. It is agreement basis. So all of them have agreed on this. But as we know, all of the discussions is about business. The turbine oil manufacturer wants to sell oil. Filtration companies, in contrast, they want to save the oil. Then the turbine OEM, they want to sell parts and services. So they have achieved a kind of optimum results and with the certain data in these gatherings. But what we need to understand today to understand every single matter behind the ASTM documents which have been published. There are other societies like STLE, which is a very famous in America, but it's a global association, Society of Tribologists and Lubrication Engineers, which their magazine is very important. They have a turbine oil committee and chair that my colleague Dr. Hobbs and Peter Dufresne, they are part of that committee on the turbine oil committee, and ICML, which is the International Council for Machine Lubrication, certifying professionals around the world. And we were one of the first companies that we implemented these varnish badge questions in ICML. So this is about EPT history. And my colleague, Dr. Hobbs, I want to give an introduction to him that, I'm a mechanical engineer many years in lubrication field. I know a lot of chemistry, but my knowledge is always limited when I talk to him. So he's a PhD in chemistry, synthetic chemistry. He manages the R&D and technical services and the lab of EPT. And he has done key contributions to ASTM D4378, which I will be discussing a lot today about it. ASTM D7843 as well, which is the varnish potential testing, as well as there is a new standard for phosphate ester fluids, FRF, fluids maintenance for steam turbines in power plants for electro-hydraulic control systems. He has got an ASTM award for increasing the knowledge and advancing the knowledge in this field. So he's quite knowledgeable and he doesn't bias his knowledge just for selling products. He's quite very senior in the industry. I would say if there are 5 people around the world that are most knowledgeable, he's on this application. He's one of the 5, and then he has got the varnish identification measurement and the VPR badge, which is varnish prevention and removal badge number 1 from ICML, because he was the main guy behind putting up all of these questions. So any question that I cannot answer generally goes to his desk, and then I will get the answers on the chemistry side. I have learned a lot from him. So myself, I think we know each other for a long time now, but just a short introduction. I worked for SKF around 10 years. I was day one interested in grease and lubricants and oil analysis and filtration. So I learned a lot in this field. And then today I manage around 12 countries in EPT Clean Oil, and these are my certifications in the area. How I know EPT is that I started a job in PDO, Shirkat Naft Oman. Petroleum Development Oman is the largest oil and gas company in Oman, where we installed, that time EPT was working with Hypro of America. Now today EPT is working standalone, making its own skits. So EPT and Hypro and myself as SKF engineer, as a consultant of lubrication in this project, we implemented around 20 machines across PDO. And then I put a condition that time for Peter Dufresne, the owner of EPT, that any sort of mechanical filtration device you put on the oil, it will reduce the varnish level, because varnish, part of it is soluble, part of it is insoluble. So MPC goes down, people think that, oh, varnish problem solved. No, but I said that I will remove the oil from the tanks. I will go inside and I will check the varnish which has been removed from surfaces. He made good promises, fixing acid number, fixing varnish potential, and removing varnish from surfaces. So the project went very successful, and I got a certificate of award from this large oil and gas company, which was my first great achievement in Varnish field. So then 2020. One, when I joined EPT, Peter Dufresne, after that SKF success case that we had together, invited me to EPT, and then I became a regional manager, Middle East and Africa. Although my career has been mostly technical, but I really love sales and talking and sharing knowledge and so on. So I implemented in each country distribution network. All of them, they're experts in the field. Today we have Francis with us from Saudi Arabia. He has been 20 years in filtration. He has done all of the filtration devices available in the industry. So he knows EPT complete difference. In Qatar, we have Nischal today with us. He worked with me in SKF before. Now he works in Qatar Trading Company handling EPT. In Turkey, for example, I selected Omar because he worked with John Crane before and he worked in High Deck before, so he knows filtration, he knows lubrication as well, and filtration. So both turbo machinery and lubrication filtration knowledge was there. In Iraq, where I'm working with the most important reliability engineering company, which is Premium Proactive Engineering, they are offering they are Mobius Institute, they are vibration into vibration, they are into lubrication as well. And Ali has been one of the most knowledgeable engineers I worked in my career. So I was not believing that Iraq market will be using EPT, but we had a very dramatic sales over there and things are really improving. So the knowledge sharing, I feel that it's very important. In UAE, Vibe Spectrum is very active. We have a very good presence in Bahrain, in Oman, and as well as in Egypt, which Dr. Mina, as a Noria trainer and consultant in Egypt, is also representing EPT, which is a very good network for me to do what I feel is right in the region. So when I came 2021 to EPT, I started first with Saudi Aramco. With Saudi Aramco, all the products of filtration has been tried. There was a 20 years of experience with other technologies. Then they tried EPT, MPC went very fast down in Abu Ghraib in the biggest refinery acid number, very good improvement. And then they put an article on the machinery lubrication comparing the technologies. So then, yeah, this approval for Saudi Aramco was one of my success cases. Then year over year, Saudi Aramco was inviting me to deliver online trainings and then to be in their online platforms and to share the knowledge across all the facilities. Being the biggest oil and gas company in the world, it's a very great pleasure for me that I can share my knowledge with them and have very, very good meetings, very good questions are asked in any online meeting I do with them. So I will try to share my experience today with you as well. The trainings we did in Qatar was also very successful in the last 2 years. A lot of good questions, a lot of um, data has been received in Qatar market. Qatar is 80% driven by our competitors. So I have been engaged with my competition in Qatar more than every other company, although a small country, but it has been occupied by our competition in the past. So it was a very good challenges I had over there, which I will be sharing with you. And the recent training I did in September 5 in Dubai was a very good success case because I see GE employees, I see Baker Hughes employees asking questions, learning from us. So it seems that there is a lot of still learning required and knowledge sharing required on this area because people feel that okay, oil is oil and change the oil. If any problem comes, we change the parts. But applying the right maintenance on the oil, considering oils and assets and considering keeping them for many years without problem really needs improvement in knowledge in the industry. So this was my introduction, and then I will just start the training part now, and then let's go. Every oil analysis laboratory that you are working with, they have other things to do. They are not just testing turbine oils, and they are getting samples from everywhere, like hydraulic oils, gear oils, even diesel or grease or whatever. And then the more tests they do, the more samples they get, the more business they make. And then they are not just expert on the turbine turbo machinery application. They do other things. They are chemists generally. They are like some of them I have seen that they have very few, very limited field experience of working with these turbo machines and to know the problem. So I would say third-party labs, they are doing a good job just testing and sending you some data. But then most of the reports coming out, they are written by algorithms. So the result comes, they are fed into computer, the automatic report is generated based on the some alarms and limits. And then these generic algorithms, normally they don't provide solutions. They provide more questions to the end user of this test rather than solving the problems. So I would say that in vibration field, most of the companies I know, they are having their own vibration analyzer, their own expertise, and they go and analyze vibration. They come and do the reporting and take actions. Very few companies I have seen that which are having critical assets, they outsource condition monitoring, like vibration job. But there is possibility to outsource. But when we are outsourcing a job critical like oil analysis, we need to really have an understanding of reading those reports ourselves because we are the owner of the assets. We should be reading those reports properly ourselves. So the next 1 hour, I will be talking on the how to read these reports, what is each test, and what is the alarm and limit on each test. So when we are looking at the oil analysis report, we need to understand that is the oil fit for doing its job? It was designed by OEM and then the maybe bearing manufacturer, maybe the lubricant manufacturer. It has been decided to do the job ISO 32, 46, or 68. These are the viscosities normally selected for turbomachinery. Means that the oil is decided to go for plus minus 10% of its viscosity during the operations. The maximum heat it can go through, it has been considered, the maximum shocks it can go through, and then a physical property, the most important physical property has been selected, which is a viscosity. And then we have certain additives in the oil which are supporting the base oil to lubricate. So we need to understand that is the oil doing its job? First is the physical properties. Is viscosity okay? We have seen 99% of the oil we have tested, which can be very good or very bad. They have correct viscosity. Normally, viscosity goes out of range in two cases, which I will be sharing. That when high increase of viscosity happens, or when we have a drop of viscosity in turbomachinery application. So viscosity need to be addressed first. If it is correct that the oil is doing its job, which is lubrication, which is separating the metal to metal surfaces need to be separated and the cooling is going on. Then we need to understand from a oil analysis report that what are the contaminants. Sometimes I see that they separate them from soft contaminant and hard contaminants. We have three, four type of contaminants which can happen internally generated in the machine, or they can come from externally, or it can be generated from the lubricant itself, which we call it varnish. So we need to understand that how much contaminant is available in the oil. And then these contaminant need to be measured. What is the amount of contamination in the oil? And then on the oil analysis report, we should understand that is my oil failing? How much time I have? Should I replace it immediately? Can I fix it with filtration? The answer to this question should be given by the oil analysis report. How much time I have? What is the remaining life of my oil turbine oil? These are all available knowledge that we should get it on the oil analysis report by itself. If it is not giving us the answer and creating more questions than the answer, then there is something wrong with this testing or the lab which is doing it, or there is a lack of knowledge with the end user of this condition monitoring test. So as I will be talking I've just repeated some people, they join later on. I go back that I will be answering the questions. Let's say now is 9:24. So let's say 10:30 I will be stopping and then I will give half an hour of a coffee break. Then I will be answering the questions which I see in the chat of Teams and then the WhatsApp group. And I open the sound if somebody wants to talk. So this is the plan of the next 1 hour. So let's go. Uh, First of all, viscosity, it's simply it's a oil resistance to flow. And viscosity changes with temperature. It's okay. It has been designed like 68 at 40 degrees, and then once the oil goes to 90 or 100 at turbine operating temperature in the bearing, for example, it drops. But the change of viscosity, it's measured at 40 degree and 100 degree. It should not be very much, and it should be within the limits. Normally, ASTM recommends when it is 5%, it's an alarm, and then the limit is 10%. So if you have a 5% increase or 5% decrease, you should be a little bit careful, but you should not go beyond 10%. So what is happening when the oil is having drop of temperature, drop of viscosity, which is too much? Then it is hot spots happening. Hot spot is a common word which is used. So imagine clearances are very low. Asperities, those metal to metal are coming in contact and causing temperatures of more than 100 degree up to 200 or even above. They can cause immediate breakdown or cracking of the hydrocarbon and cause the lubricant to have a viscosity drop. Imagine if a viscosity drops and then you are not testing it properly at the right time, then the metal to metal contact happens, heat takes over, and then the viscosity increases because oxidation material, which is the heavy polymers, will be produced, and then you will have an increase of viscosity at the end. So sometimes there's a short term viscosity decrease due to some random and some issues and some mechanical faults and so on. But it finally ends up in the increase of viscosity. But then some other issue I have seen that the viscosity can decrease because of adding some solvent or adding some lower viscosity oil by mistake. Because in the industry, I have seen that they are using a common filtration device, for example, for different type of assets. They are using it for like the same filtration unit is being used for turbine oil. Then they are doing a gear oil, and then they're doing the other pump oils. For example, if the oil is 68 in turbine, then they are doing a 46 hydraulic oil. So if a 46 is mixed with the 68, it's going to bring down its the viscosity. And then if there are different oil formulations, it's easy to catch it with elemental analysis, which I will be discussing today. But if it is the same type of oil, turbine oil, which is 32, 46, and 68, they are mixed up during these filtration practices, then you cannot understand why it's happening. Mostly by a site visit, you can understand. So these are my comments on the lower viscosity. Then on the higher viscosity, normally the lubricant by aging, its viscosity increases. We darkening the oil, the high chain and high weight polymers formed because of oxidation and breakdown of lubricant, they increase the viscosity over time. Very dead oils like high life of oils, long years of usage of oil causes the thick oil to form, but it can be also high amount of varnish and high amount of solid as well causes increase in viscosity. But we have seen that this viscosity issues comes at the later stages. So you have antioxidants, you have additives to care about those materials which are formed once the antioxidant is below 25%, which I will be discussing later. Then you have this formation of materials inside the oil that will increase the viscosity. So generally, be careful about viscosity and just check it at 40 degrees enough, no need of 100, and then check that it is not beyond 5%. Labs are doing it, they are writing it for you, but what I recommend, this oil analysis training is about turbine oils. But if you have gear oils, for example, on site, and it is 460 or 320 viscosity, always measure the new oil viscosity because the plus minus 10% is for the production as well. The oil can be delivered with a plus 10% of like 320 viscosity. So always you need to know your baseline, then your oil analysis will be mm, considered from the baseline, because if your oil is already made by the lubricant manufacturer, for example, gear oil is coming 340 to your site, and then you are checking against 340, then your baseline should be exactly 340, not 320. I have seen most of the labs, they are considering the nominal ISO viscosity grade as their baseline, because the baseline sample is not given, and then they need to really measure the viscosity of the oil delivered, and which is really put in the oil which is put in the system. That should be our baseline. Normally, we cannot fix the viscosity issues. Once it is very lower, once higher, it's a complete recommendation is replace the oil. So let's go for contamination. Once we have contaminants inside our system, we need to understand what they are and how much they are. If they are particles, they are solid. We call them insoluble, solid, or particles. We need to measure them, how much they are, and then what is their source, what is their size. And then there is an inline filters of the turbo machinery by the design of the OEM, which is removing part of the solid, but some of the solid is passing through those filters. We should understand what is the target of amount of solid in these systems. And then let's go for the another type of contaminant because water is always there in the air, in the moisture, in the air around the system. And then by temperature changes between day and night, the and also when you stop the machine, the water can go inside your oil. So water in the oil is three forms. It is dissolved, it is emulsified, and free water. We need to understand that how the oil, normally in turbo machinery, we have high amount of oil in the tank, how it is interacting with the air and what are the water sources, if water is coming from the ambient air or if it is the water is coming from the cooler is leaking, where is the source of water, how much it is, and has it caused water separation issues or not? Because the turbine oils are made to be separating from water, and a certain additive is there. So the oil is non-polar, if you remember, and water is polar. So they are made to be separated fast. But there is a problem here that the varnish is polar and water is polar. So there is something which is keeping the water inside, not allowing it to go outside, that we need to discuss it today. And the demulsibility issues and water separation issues in steam turbine applications happen. And then the solids in the system, they can be metals, and some of them they are dissolved, and some of them they are coming out as a dissolve. So they can be additives, they can be also contaminants. We need to understand what are the dissolved metals by the elemental analysis. If you know that ISO particle count is measuring above 4 micron and then the elemental analysis is measuring below 5 micron. So we need to focus what is dissolved, what is the small, and what is the bigger one, and how much they are available. So let's focus on the contaminants. Uh, on the particles, this test has been many years. There are different standard for this, like NAS in America, and then ISO 4406, which is the most comprehensive test nowadays. I have seen in the industry that, today I'm not just delivering a training, it's a knowledge sharing experience. It's just sharing my experiences as well. I'm not just delivering a training today, especially because of your weekend. So I'm trying to be more practical rather than just a theoretical training. So ISO 4406 is mentioning to us with three numbers, amount of particles with a certain range. So the first number is showing the number of, so it's a population, number of particles above 4 micron. Then the second is number of particles above 6 micron, and the third is number of particles above 14 microns. So the laser counters used in these applications, in this test, sometimes they count bubbles as well as solid. And if this is solid varnish scattered too much, sometimes they count them as also solid. But we need to be a little bit careful about testing the new oil that we are putting into the machine, and we need to know the contaminants inside it because particles are available in new oil as well. The new oil made in the refinery is not clean, it has particles as well. So we need to count amount the number of particles, and then we need to have a target about the cleanliness of the oil. ASTM D4378, which is the guideline for turbine oil analysis, is considering limit of 18, 16, 13 as maximum. This is the red light. I have seen turbines having 20, 22, 21, whatever. This is like gearbox in a cement plant. So this is the red line, and then the life of your mechanical components will be dramatically reduced when you go above 18, 16, 13. This is a turbine oil example I have here that you see 25, 22, 11, 199,000 particles are available, more than 4 micron. and the target was set here 16, 14, 10. So why we sometimes put the target 16, 14, 11. Each digit lower in ISO particle count means number of particles to be half. So why we go sometimes cleaner and we need less particles inside our oil? Because the components are more critical and the components are more sensitive. 18, 16, 13 is considered for journal bearing application, which is only lube oil in the turbine oils. But if your turbine oil is lubricating as well or is used as well in a common application going to hydraulic circuits, then you have servo valves which they have tighter clearances. So you need a cleaner oil, you need a less number of particles, which this will cause less damage. So 16, 14, 11 for the systems which they go, the oil is used in hydraulic system, 18, 16, 13 for the system which is having a just journal bearing as a lube oil application. So I really want that you focus on the number of particles, because once we do filtration, we are removing particles. Filtration is against the we don't know the source of it. We are just removing it by the size or by the mass, and we want to reduce this number. The number lower, the number this is better. The lower the ISO particle count, the better for your machine. So the cleaner the oil, the better for your mechanical components. But always there is a cost for it, and how much clean we should be. We should have this limit, really, we should not cross it. This is not our target. We put the target always 16, 14, 10 in EPT, regardless it is journal bearing or it is hydraulic application. We put it 16, 14, 10. The beta ratio, the filtration efficiency of your mechanical filters, as well as the micro rating, affects how fast you get these results and how much is your filter consumption, which today afternoon in the technical part of the filtration, I will be discussing about how to achieve these results. But just as for you to know that, for example, this oil is having 25, 22, 11, and the target is 16, sometimes it's not causing a big shock. I see that vibration people are very, very uh, particular in numbers, and they follow percentage changes of overall vibration. I don't know. They focus very, very detailed on every single digit. But if an oil analysis report is coming from like 25 and 16, they feel not a big issue, because the oil problems mostly they cause later the problems. They doesn't come, and they show it on the failure of components, but they are not really directly linked to the oil issues. So you see here 25 is 512 times worse than 16. This is the way I write it. So every digit higher means 2 times more particles. So we need to be a little bit careful about the number of solid particles in our system, put the right target, and apply the right filtration to achieve that target. Then let's go for the water. Then I would say that water is source of oxygen, so it increases the oxidation rate. It's polar, so it is using some of what the additives. Additives are polar, so they are attracted to water, and then they are taken out from the oil. Then the water causes acid to form. Water has a lot of problem, makes a lot of problem for the oil, and then we need to understand that the oil is non-polar and the water is polar, so they are not mixing very well with each other. So water comes out, and then the water content of the oil is dependent on the temperature. When you have hotter oil, it keeps more dissolved water inside. We have three forms of water: dissolved, we have emulsified, and then we have free water. The higher the amount, then the water goes to different forms. So dissolves are scattered molecules of water. The less than 200 ppm on the mineral oil is normally dissolved. Above 200 ppm, depending on that temperature and that condition, then the oil becomes emulsified. Emulsion forms means that the oil, the water molecules, they are attracted together, and then they form a oil molecule, water molecule, which they are attached together, and this emulsion is not lubricating anymore. Is not your oil which has a property of lubrication. So then emulsion forms, and then removing of emulsion is so difficult with the filtration technologies available for water removal. Most of these turbine OEM, they send a centrifuge along with their system. And this centrifuge is only good to remove the free water and big particles. Once oil is trapped inside the oil, sorry, water is trapped inside the oil as an emulsion, it's so difficult to remove it with the technologies which are. Uh, I see somebody commenting. I cannot see the slide. I think everybody can see the slide. Let me just stop it and come out, waking up everybody. So everybody can see this. I stopped it now to say Salamu Alaikum. I think you see my screen, just to say yes to each other. Yeah, you see me? I hope I am sharing a slide again. Just write in the comments. Thank you. Okay, I share again now. I am looking at my phone as well, is next to me, so the screen is shared and everything is possible. Yeah, very good. I am checking my screen with my phone as well while presenting on laptop. Okay, so on the water issue, first we need to know how much water is inside the oil. There are different tests around the years designed for water content test, but the most precise method to know even 50 ppm of water, low amount of water, has been a test called Carl-Fisher, which is the most important test for the water content. Labs, they have gone through, because Carl-Fisher agents are expensive and it is the expensive test. So they have gone to make it simplified. So there are relative humidity sensors in the lab. There are FTIR, is the Fourier transform infrared test, which they pass infrared. They get a graph and they can estimate the water content of the oil by FTIR testing very fast. And the crackle test, which is just an on-site test, some labs are doing it. They put the oil drop on a hot plate, and then the more water it has inside, the more you see the crackle sign. So the water droplets are like exploding. So these are like, I would say FTIR and Crackle are above 500 ppm or above 1000 ppm. Sometimes they're accurate, but there are online sensors as well coming in to show the water content, but the accuracy is not up to the level that it shows by Carl-Fisher. I would say that it's very critical application, and we need to really use the Carl-Fisher test. And we discussed about repeatability a lot today, especially when we talk about ruler test and as well as antioxidant testing. You know, when you do the same test in the same lab with the same oil two times, there is an error. And then the same oil goes to two different labs, same oil, okay, goes to different labs, different equipment, different technicians. There is an acceptable error. This repeatability and reproducibility errors for each oil analysis test is defined. For the FTIR and Crackle and other tests, this very high amount of error can happen. Even the same lab does it two times. So Carl-Fisher is very reliable and less error, less repeatability issues. So really, we need to do Carl-Fisher test for our water content. So be a little bit careful here that turbine oils, mineral oils, they become saturated at 200 ppm maximum. So this is the maximum amount of dissolved water they can keep in. Above this, emulsion forms, emulsified water forms, and demulsibility issues happen. Demulsibility is a test in the lab they do to make sure that the water is separating from the oil easily. No emulsion is forming. So above 200, we have, sometimes we have it even with 100. Why? Demulsibility comes into picture because of varnish issues. Water is polar, remember, varnish is polar. So they attract each other. So it's kind of trapping the water inside. So one issue in the water is the water content. So we need to reduce it to below 200 ppm. Then we need to really separate the water easily, and the water separation is also need to be fixed. Regarding synthetic oils, because ISTM D8323 that I will be discussing today is designed for phosphate ester oils. Any sorts of ester, they keep more water inside because they're highly polar. And the issue with the esters is that they keep more water inside, but when water comes in, the reaction can go reverse. And then during making esters in the refinery, the water was part of the manufacturing of ester. When your water comes in, then it can be damaging the oil, and it can be going back to its like it was made. It will go just like it will be completely damaged. So we need to really keep 300 to 500 ppm maximum for ester-based lubricants. not more than 500, because they can, water is source of oxygen as well. So it causes breakdown. So maximum 500 for mineral oils, maximum 200 ppm. I have seen a lot of steam turbines running with much more than this water content. And the water source is important as well. If it is ambient air, we should have a solution for it to stop it not to come in that much. And then proper water removal technology, as well as then if there is a steam leaks. I will share a project I have done now in this slide that in Turkey, one of the steam turbine oils was having demulsibility failure with just 300 ppm of water. Water was not very high, but the emulsibility test was failing. And then the recommendation from turbine oil company was that, okay, change the oil, turbine oil manufacturer. So I was just pushing that, change the oil, then issue will come back again. So they changed the oil, the issue came back again. And then I investigated that where the water coming in, even 300 ppm. So they stopped the machine and they checked the seal, and there was a leak from one of the seals that the moisture was coming in. And then once issue solved, then the emulsibility issues also disappeared. So we need to find the source as well, because not always this just filtering out the contaminant is the solution. We need to find the source of contamination. So um, we'll discuss today about the emulsibility problems. First of all, we need to remove the water as well as remove the varnish at the same time. So there are different technologies used for water removal. Centrifuge removes only free water. So let's say above 500 ppm is good. Below 500, it cannot really affect much. Coalescer technologies has been used for gas and oil and lubricants to remove the water. So they collect the water droplets together, join them together with a special media, and then they separate it. And then, sorry guys, I cannot read the chats now. During the break, I will be reading it. And then, vacuum dehydration is the most efficient way of removing water in any format, but it is stressing the oil. The vacuum pump itself, it fails a lot, and it's a very costly way of maintaining the water level. But if you have large amount of water inside, like 5,000, 10,000 ppm, and you need a quick solution, only solution is vacuum dehydration. One of the solutions that we have been working in is that also OEMs, they consider putting a dry gas blanket on top of the oil. So no air coming, ambient air moisture is not coming in. So having nitrogen, dry nitrogen flow on top of your oil is always a good solution. It doesn't allow the moisture to come in, as well as is removing water from your oil. 50 ppm, 100 ppm per day is being removed. So the emulsibility is one of the problems of steam turbine oils, as well as the water separation and water removal is also a challenge that I will be discussing today afternoon. So the emulsibility test is a 40 milliliter of oil, 40 milliliter of water mixed together, and then we give them the time to separate together, and then the forms which are water forms or the oil forms that are shown after the test are measured. So it's reported as the amount of oil, amount of water, and amount of emulsion which form, and then the time which takes to separate. The more the time, it's more dangerous, because we can suck the oil to the machine, and then we need to give the right time for the oil to water to separate. So the lubrication system design in the OEM has been considering that if the water comes in, we need to give the enough time for the oil to separate from water, and then the water is drained. But once the emulsibility issues happens, then it takes more time for the water to separate. Then there's a risk of sucking this emulsion and sucking this oil, which has this emulsion issues, the emulsibility issues to the application. Then it causes bearing failures and corrosion, and then free water in the tank, and a lot of issues. Remember that the oil which is hot and having this emulsibility issue, when it is cold, cold oil keeps less water inside. So it will be as a free water coming on top, bottom of your tank. So we need to be very careful to remove all sorts of water, as well as the fix the emulsibility issues. Then regarding metals, I just want to go back to the agenda of today, that to make sure that I am on the right track. So on 10:30, like around 15 minutes, 20 minutes more, I talk, and then I give the break to talk and answer the questions. I will finish the oil analysis part in 15-20 minutes. So on the elemental analysis, because we counted them, how much they are the solid, and then we now we need to know that what is the source of them. We know the amount, but we need to know the source. When we are checking the oil analysis of a new oil, we understand that there are some metals used in the additive package of the oil, like zinc and phosphorus and the other metals which are shown here. They are part of the additive package used in the oil to act on the surfaces and do a reaction. Like ZDDP, for example, is an anti-wear, which is like I call them chemical layers or chemical carpets. Imagine that you have these asperities, sharp edges of the bearing surfaces or gears and so on. And these additives are anti-wear additives, for example. They act on the surfaces. Then you have antioxidant additives, which are not really measured as metals, which are chemicals, which I will be discussing about ruler test later. But if there is a metal source and used as additive, we can know it by the elemental analysis when we test a new oil. So what happens when you have zinc and phosphorus as additive, then it will be going down. The additives will be used up during the oil consumption, oil usage. Never additive should go up during if the no oil is added, no top up has been done. Normally additives should go down, should never be increasing unless there is a wrong oil added. I mean, my point is that additive level of a new oil, you should not have a higher level always in used oil analysis. For example, if it is 80 ppm of phosphorus or 80 ppm of zinc available in your additives in the new oil, you should not have a higher number in your oil used oil analysis. The additive cannot be higher than the additive of a new oil. Then on the wear components, when the tank can corrode, metals can flake off, bearings, filter elements, anything which is oil in touch with can wear off, can come to the oil, which we see this iron content, copper, chromium, nickel, titanium. So these are like normally wear elements of or components used in the machine, and then they can come from outside as well. Like silicone, which is the main component of the dust in the environment, can come into the oil as well. So ASTM D4378 gives a complete list of all these elements and the sources they can come in. We should not really be memorizing all of them. We should have these tables around us and to see that where each one coming from. And the labs also, they have this. Normally labs, the amount of the ppm, which I will be analyzing today after this oil analysis part, the ppm level of each wear element and also additive level, it should be clearly defined in the base oil analysis, like I mean baseline, as well as how much is acceptable to have an increase. It's very important. If your iron level, the elemental analysis is going high, 2 times more, 3 times more, then you have started having a problem. Remember, elemental analysis is just counting the smaller than 4 micron. So a small wear causes little bit of wear elements to be produced. Then each particle of less than 4 micron can bring many bigger particles later because of wear. So it will show first in elemental analysis wear components, then it will be showing up in the iso particle count later on when the breakdown is more and wear is more. So yeah, we will analyze together the elemental analysis of some around 1.5 hour of workshop. I will be analyzing a lot of oil analysis reports together. And then is my oil failing? So the amount of acid, I focus on acid a lot because the acid is the breakdown of hydrocarbon with the air, is the main varnish precursor as well. Acid is the first breakdown product of the oil. It's the longest and oldest test that humans have been using uh, for knowing that the oil has failed. So we need to know the acid number of a new oil, acid number of a used oil, and then to know how much it has increased. Many I have seen from 2014 so far with EPT that strong acid is being reported. Many people, they know just total acid number and they don't really understand that weak acid and the strong acid presence is different. And then is all filtration technique removing acid as well? Because Many people I see, they top up, they put a new oil into it, so the acid number is going lower. Well, acid number is increasing when you add the oil, like new oil. It bringing down the acid number because of some new oil came in, but it's not really removing the existing acid, which is already your oil is saturated from the acid. So we need to remove the acid, not just reducing the numbers by just faking the results by adding some top up oil. And then the thermal varnish, which has been defined for many years. All of these breakdown products, they accumulate in the oil and then they come out as a solid and they stick to surfaces. So we need to define that what is the meaning of varnish and then how it can be tested. So let's just focus on acid for now. So I discussed about weak organic acids, and then on the esters, we have. I will just see that I will make sure that I will be answering all of your questions. So you are putting your questions in the chat. Yeah, I will be coming back to all these questions in the break. Okay. Thank you very much. Just give me some time in the break. I will be answering the questions. And then, sorry for that. The acid is a varnish precursor. The word precursor is a starter, like it starts with acid and then later on will be varnish. So we need to remove acid and remember that the more polar is your lubricant, like esters, like synthetic oils, they make stronger acids. And then acid removal is more important for those group 5 ester-based lubricants. So there are two very, very important matter here that this is the oldest test method available for checking any sort of oil in oil analysis, but many, they don't really focus on these two tests available. There is a test called visual method D974, ASTM D974. So the acid is acid, so the base is added to the oil to make a reaction, and then it's called the colorimetric method. By the color change, when this base is added to the acids of the oil by the reaction and the color change, the amount of the acidity of the oil is reported. So it's a colorimetric method by the color change, by the technician who is doing this test in the lab. It's being reported. Many people they are colorblind. They can report it by mistake, but there are cases that we can use D974, but it is not as accurate as D664. So potentiometric method, it's simply using electrical charges or changes that happens when you add the base to the oil which has high acid numbers. And by the potentiometric method, exactly you can measure the acid number, strong acid number, as well as the total acid number. So I would recommend that ASTM also recommends that for turbine application you use D664 and never compare the results of two different test methods. If the lab is doing 974, the next test should be done 974. Different labs which are doing different test methods, we should not be comparing with each other. I mean, it should be the same test method. Even the same test method, different lab, they have some error. So we need to stick with the D664, which is very reliable. An electrode is really measuring how much the changes happens in the oil and measuring exactly the acid number. So for the diagnosis of acid number, we will have a lot of examples, but let us do 664 first to make sure that acid number is correct and then correctly report. Then let's go for varnish. Varnish is defined as oil insoluble product or the oil solid product is generated by the oil. Imagine your tea is generating sugar and the sugar is generated all the time and the oil is hot or the tea is hot, it is keeping the sugar inside, and then the oil is cold, the sugar comes out, so it cannot hold it anymore. It is causing valve sticking, causing filter plugging, high temperature operation because it's kind of insulation on the layers. It causes cooler performance issues, and then it's a number one reason of the oil failures because high amount of oil in turbomachinery applications. The test called Varnish Potential was designed many for measuring the varnish potential. Why we call it varnish potential? Because in the oil analysis, in the condition monitoring data, Like imagine vibration. You are measuring the point displacement, velocity, or acceleration. Exactly, you are measuring that point condition on the asset. But on the varnish, we are not measuring the varnish on surfaces. We are measuring the oil saturation level, how much varnish is inside. It's not measuring varnish on the surfaces. So it's called varnish potential. And then it's a patch test. Is a patch is a filter element. It's a 0.45 micron biggest pore in this filter element. So the oil is taken out from your turbine is around 90 degree or 100 degree. It comes out. Remember, part of the oil is soluble varnish is inside, part of it is insoluble varnish. And then the balance changes when you take the oil out of your turbine. So there is some soluble varnish inside, some insoluble is out. So the oil comes to the lab, is a 1 day heating at 60 degrees to reset the oil to the working condition, then 3 days waiting in the dark for the some part of varnish to come out. And then at the end of these 4 days preparation, a non-polar solvent is added to the oil. You remember oil was non-polar, varnish was polar. So non-polar solvent dissolves all the non-polar molecules and then they crashes out all the polar molecules. So uh, using this solvent, we crash out whatever is polar inside the oil. So it's a saturation test actually. So bring out all the varnish molecules from the oil and then filtering it with a 0.45 micron patch. So once we filter it, it will be captured. Whatever bigger than this value, it will be captured on the filter element. So the darker the patch is, the more saturated is your oil from the varnish inside. So the point is that, like many years ago, the latest one is updated 2021, which I will tell you what does it mean, this CD7843 2021. So many years ago, which test was designed? It was designed for Group 1 API base oil, which was used in turbine oils. What does it mean? It had some sulfur, it had some nitrogen from the manufacturing of the base oil in the refinery. So the oil was little bit polar that time, and this brownish color was coming from sulfur and nitrogen from the breakdown of the lubricant. So the varnish was brown that time when 20 years ago MPC test was designed. Nowadays, the turbine oils are having I would see that MPC was considered. MPC, so what's MPC? Once the varnish is captured on the filter element, they use a spectrophotometer. The test is called membrane patch colorimetry. Using the color intensity of the different colors available in this patch, they measure the color intensity and then report it as MPC. MPC is reported as a color intensity or delta E value, and the darker the patch is, the higher the MPC is reported. So many years ago, when MPC test was designed, the color of varnish generated by API Group 1 oils was completely brown, and MPC below 15 was considered good. So the oil has less propensity to make the solid varnish, we call it. MPC above 15 was considered up to 35 elevated issues, and above 35 critical. So this was the old way of diagnosing MPC. It was acceptable between many. And then that time, even MPC EPT was telling everybody in the industry that MPC is measuring soluble and insoluble varnish together. If MPC goes even below 15, still soluble varnish is inside the oil, but it is causing less harm. But once it comes out very fast, then it is more chance of varnishing in the system. We have been telling the industry that MPC near zero means no deposits. MPs nowadays, the turbine oils are like watercolor, no sulfur, no nitrogen. There has been a lot of hydro finishing. Hydro cracking means that hydrogen has been pushed to the base oil, and then no sulfur, no nitrogen. I have seen in compressor applications of turbine applications like a pale brown varnish. I have seen nowadays. I don't see any more brown, dark brown varnish anymore because the oil itself is very like water. You know, it doesn't have the golden color or oil color, and it has been highly saturated by hydrogen. It has been all the impurities has been removed. So breakdown happens, but the varnish is not colorful like before. So we need to be really careful that MPC around 10 it can be your oil is already saturated and causing deposits. But now let's see the power of the OEMs, big OEMs of turbines, the power of oil companies, and then the power of EPT has been finally for the new turbine oil formulation, delta E of more than 20 is mentioned now. So they increased it even. MPC was 15, 20 years ago. Nowadays, MPC 20 is called warning. So we need to be a little bit careful. MPC above 30 is called action. So, but being honest with you, for me, MPC near zero means no risk. It's a risk value. So you don't wait for the MPC 20. You can have turbine oil failures and then also bearing failures due to varnishing. So yeah, then these are the I have seen labs that they are not using the patch which is 0.45 micron, like I have seen a zero point 0.7 micron patch being used as well, which is it's a nitrocellulose material, is expensive, so labs sometimes are not using the proper patch. As per D7843, they should be reporting that the 1 day heating, 3 days waiting is really happening. If this is not done, MPC is reported free properly, and then if it is done properly, MPC comes to 20. So I have seen that people bring a spectrophotometer on site after their unit is working, their filtration unit. They do the MPC test same day in front of customer to show that everything is fine. So this is not right. MPC is a 4 days test. It should be done properly to take out all the varnish inside. So soluble varnish should be crashing out and then MPC reported. So there is an update with MPC way of reporting. We have seen in the industry many years that there's a black carbon formation. So high temperature events like air bubbles, they go and explode in high pressure areas when, like in hydraulic applications, like filter sparking events has happened, which cause around 200-degree temperature. Those high temperature events, they cause black carbon to form. So hydrocarbon to be cracked, that we call it thermal cracking, and then the black carbon to form. If the lab is not expert, we'll be calling this patch varnish as well. So, but this is not varnish. So in the spectrophotometer, when we were using it for delta E, which is the color intensity of the whole patch, different color contributors can be reported separately. Delta L is showing how much black and white is. Delta A plus B is showing other colors. So nowadays, if there's a black carbon formation, we can separately report it. So if delta L is high, you have black carbon formation, which is an engineering issue. We need to find why high temperature events are happening. Removing black carbon, which happens only with electrostatic filtration. We need to really define it. I have seen it in journal bearing applications as well, which there is a negative clearance or preload happening, but more in hydraulic systems, this issue happens. But if it is only delta L, delta A plus B is high, it's a normal varnish, normal breakdown. But delta L as well, it can be covering each other. Delta A plus B can be behind delta L. So if the lab is not really expert and not separating the, let's say, carbon issues and with varnish issues, it can be completely separated with the proper reporting of the ASTM D7843 with the proper reporting of MPC test as per the latest uh, version of the standard. So we in EPT, if it is electrohydraulic control unit, for sure we do the MPC reporting this way, which is recommended in ASTM D8323. But in the lube oil in Turkey, I have seen that some black deposits I have seen on the journal bearings as well. So it's always good to know, because this black carbon is, the patch in the MPC test was 0.45 micron. That is the reason it's capturing it. But this is less than 1 micron. No filter element can catch it. You will not see it in ISO particle count. It will be passing through filters. It will not be showing in anything. In elemental analysis is not shown. In ISO particle count is not shown. So the best place to see this black carbon is on the MPC test. And in the MPC test results in EPT, we always report the patch photo we add to the oil analysis report as well. We don't report just values. We report the patch photo is included in the oil analysis report as well, so you can have yourself a look at the patch of the MPC test. So let's go ahead, and I have around 10 minutes more on the oil analysis part to finish. So we need to know how much is the remaining life after we know the contaminants and the issues. So the antioxidants, they are formulated in the oil. They are the main soldier which they fight with oxidation material. They make them less harmful, and then they give more life to the oil. So once antioxidant they consume over time, they become less than like a 50%. The acid number starts to increase, the varnish potential starts to increase, and then the oil starts to fail. So we need to measure the antioxidant level of the lubricants all over the time. So ruler test, which is the old commercial name for the device which was designed for this test, is called linear sweep voltammetry. Using voltammetry, they can measure exactly how much amine and phenol is remaining in your oil. Some oils are formulated with amine alone, some oils are formulated with phenol alone, some oils are having a combination of both of them. Phenol is a secondary additive which is failing first or used first, and then it's protecting amine. So both of them have different functions. One is working on the high temperature side, one is on the low temperature side. Both of them, they are working as the antioxidants, so they support base oil to work in the better, so to fail later. So they are the main soldiers of turbine oils, and then we can measure them. The point I have seen in the industry is that many people are focusing on the numbers too much. These two tests, they have big repeatability issues. In the same test, same day, same lab, even EPT lab does the same test, you can get two different results. So it can be reported 90% amine, same day. You do it in a couple of hours, you can get 80%. So you need to really know what is the repeatability errors of the test you are having. So only do the trending. This year, this month is showing 90% antioxidant remaining. Next month is showing 80. The next month is showing 70. So you are having a drop of antioxidant level. You need to be knowing that what is RPVOT. RPVOT is a rotating pressure vessel oxidation test. This test is not measuring antioxidant. It's really breaking down your lubricant. Lubricant means base oil plus additives. Then you can measure how much your oil is resistant to oxidation using this test. It has been originally designed for the turbine oil OEMs to break down the turbine oils to make sure that their assets is reliable. So faster in the lab, they can break it down. To be honest, a lot of additives has been used to increase the RPVOT values. The RPVOT of new oil is good to just buying it. If your RPVOT is fine, it's above 1000, whatever minute is being promised by the lubricant manufacturer. But it's not a very good test for the condition monitoring because RPVOT doesn't drop until you have less than 50% additive. So you have 1%, 2% per year if your additive is still 50%. Once additive is going below 50%, immediately RPVOT is dropped too much. So your life of your oil is already 50% gone. Then RPVOT starts to drop big values. So be careful that you need to measure year over year how much antioxidant you are losing, and then which turbine oil is consuming more additives. You need to be careful. More problems comes where you have more additive consumption. 20 years ago in EPT, when this discussion was happened about the oil is failing due to additive loss, let us add additives. And then varnish, the issue of varnish is solubility and the polarity. Let us add some chemical to solve the problem. This was tested in EPT and it was failed. And then I will tell you afternoon that why this is a failure. And then industry, unfortunately, is using it worldwide nowadays. But I will be sharing with you the on the analysis part, how we need to be careful about additive consumption and the RPVOT values. Be careful, repeatability and reproducibility errors of RPVOT as well as ruler test are very high. Never compare the results of different labs. Compare only the same lab with itself and then do the trending. It's very important if you're comparing different labs, you need to consider that if it is within the range of the repeatability error of the same test. And then uh, I just want to finish this oil analysis discussion with the ASTM International. It's American Society, but it's a really international organization. Many years of knowledge has been collected. ASTM D4378, it's in-service monitoring of mineral oil for steam turbine, gas turbines can be used with this guideline. Each test has been discussed. What are the alarms and limits? Mostly, unfortunately, limits, alarms has not been discussed much, but the very important document, you need to check your oil analysis reports against this document to have more knowledge about what the OEMs, what the turbine oil companies, what filtration companies has agreed on the testing to be done. DA323 on the FRF, phosphate resistant for the electrohydraulic control systems of steam turbines. This is all the standard for other power plants equipment like gear oils and others you have. You can use the D6224. It's 2016 is a little bit outdated, but still can be used. It's a very good resource. So I will give you, I will just answer the questions now, and then I will give you a half an hour break before I start my um, oil analysis workshop, which I designed for you. So let me read the questions that I have here. Then I will check the WhatsApp group as well. What are the key indicators that must be measured to assess the lubricant condition? What are the targets? Yeah, we discussed about this, and it should be physical and also chemical properties need to be tested in the oil analysis. I will be discussed, and you should place your target as well as the limit to know how far you are from the target. And why ester-based oils? They are polar. Water is polar, so it keeps them more inside. It's not incompatible. You know, mineral oil is non-polar. Water is polar, so non-polar doesn't dissolve in polar. In chemistry, polar dissolves in polar, non-polar dissolves in polar. That's the reason ester-based oils or synthetics generally keep more water inside. What sort of kits are required in-house mini lab for sampling or analysis? This is outside of this discussion, but you can use, you can see the company is called a Spectro Scientific, and there are many companies offering oil analysis labs. But I would consider that the labs on site should be done for the quick tests to know viscosity, acid number, and water content. But the expertise required, and as well as the expense required to have more expensive testing equipment, then better to use an international lab in your country or near your like I know you are from Africa, so there are good labs in South Africa, which is a shipping lab to South Africa for you. It's not that difficult. I know in Morocco, for example, has SCS, and then you have global labs in Africa, which I will be feeling that only turbine oil going there is much more easier for you. But on-site testing, I would recommend to do it particles, acid number, water content, maximum. These three tests to have a quick overview of if there is any big problem. What tool or technique is used to semi oil particles out of a new oil? Same laser method is used. The ICP method is used as well for the elemental analysis for particle count. ISO 4406 we are using for the particle counting. Yeah, a specific test I will be mentioning in few minutes. I will be mentioning that which tests need to be done. I am analyzing 1.5 hour, Mr. Ghulam, oil analysis test results. So just give me a few, just in 15-20 minutes, I will be focusing on each test and on diagnosis. So Ali, what do you mean by MPC membrane patch content? Why are silicone containing sealants not recommended for sealing joints in oil containing machines like gearboxes? To be honest, this is out of my knowledge. I mean, silicone for me, I don't have this knowledge, brother. Let me study this one. I would say no, sorry for that. I don't have this knowledge. Do you know relative humidity online system that can be plumbed for continuous monitoring of water? Yeah, Danish, we are working with a company based in Spain, but I will not. I will be writing it in WhatsApp group later on. Okay. Regarding these sensors, please share your thoughts on how to stop electrostatic charge accumulation from group 2. Yeah, I will be sharing that one in the filtration side. Yes, Ali, sure. This in the afternoon I will be answering that. Mobile glycol oil for wet screw compressors. Yeah, this can go up to 2000 ppm, Mohammed Ben Yatla, brother. Depends on there are two type of glycols. You need to send me the data sheet. I think you share the data sheet. Give me some time to. There are some of them water soluble and water insoluble glycols available, but it's very high amount of water they can hold. This type of oils. I will be sharing with you the details. Okay. What would be the counterintuitive if I use 1 micron, 3 micron in absolute filters? Yeah, now 1 micron for sure it will be removing the faster the solid you achieve the targets much faster. The point is that When you use 1 micron instead of 3 micron, then you can have a filter consumed much faster, then causing also the pressure on the filter element, so it can be disturbed. So you need to really calculate how much flow and how much volume of oil is going through it to go for this change. But generally, you will have a better performance, but beta ratio as well need to be considered, not just the micro rating. So beta ratio is the filtration efficiency of the turbine, of the filter element. So okay, just have a look at the WhatsApp group as well. I think there is not much in the WhatsApp group. Okay, thank you very much. I will just continue a few more slides because before going for workshop, I need to give, because also Mr. Ghulam was asking what the standards. This slide give details. So better to follow D4378. So we will go through each test. MPC, acid number, color test, emulsibility, additive test or RPVT, viscosity, particle count, water and wear metals. And if required, we do foaming, air release, and raster flashpoint if needed. These are not routine tests. And then we will be analyzing each of them. Some of them is recommended to be done monthly, and some of them quarterly, the standard, which we need to follow that. I have seen that people, they do once a year, some of these tests, which is not really suitable. And then for D8323, which is the phosphate ester for control oil systems for steam turbine, you have other additional tests because resistivity is important for this oil, which I will be discussing. This oil is made full of additives. It's like an additive. It doesn't have any base oil. So phenol level is important. It's a breakdown product of this oil. Particle count is much lower. Water content maximum 1000 ppm. So this is our recommended targets and limits for these two applications, which I will be analyzing, let's say at 11 o'clock, like now it's 10:20. At 11, I come back. Now I will open up the microphone if you have some questions. I will be here now. This is the break time if you want to go out. It's a 10:20 Oman. Up to 11, I will give a break, but I will now open the, let's say, microphone. If anybody wants to talk to me, I can talk to them. Your microphone is open now. If you have any question, you can open it and talk to me face to face or what.
Keshav, this is Danish. Do you have any experience on anti-static oil filters?
Yeah, we were using them when the filter elements causing a sparking events. You know, the accumulation of charge on the filter element and sometime sparking events happening. It's there are materials which they support these discharges not happening. But the I have seen that they are very supportive. They are very helpful. But if the accumulation is there and this problem is there on the filter, when we use these filter elements, it doesn't damage the filter. So filter is safe. But then it finds it in other places in the system to be discharging. So when I had these filter sparking events and I put these filter elements, the filter is safe now. So no sparking even in the filter. Then it goes to another location. So I would say that in that project which I was working and using these filters, it increased the life of filter element a lot because varnishing was happening and filter replacement filters were damaged a lot by sparking events. So using this anti-static, like, or let's say these filter elements which are designed that the sparking events doesn't happen for them, they were really helpful for me, which the filter element life increased, as well as we had the varnish removal done at the same time. So but the issue was showing itself on the shaft and bearings in other location, which I understood later on. Because we were saving the oil, we were saving the filter, but the problem was the earthing or the design of the this turbo generator. It was a generator, turbine generator set. So on that case, for me, that experience I had is that we saved the filter element, which was very successful, but the problem came out from somewhere else.
Okay, thank you.
Uh, I have one question. My name is Aibar.
Yes, Ivar, please.
Uh, how is it creating is foaming inside of the oil? Bearing housing example with the machinery, turbo machinery or pumps, and the oil gas. We every time the operation team and create a notification foaming oil. How this one is created?
Good question. So foaming, let's define it first. The air is having inside the oil, you have air bubbles. Air is having dissolved in the oil. Air is inside the oil as well when it is poured inside the drum. So when you are from the drum, you are putting it into your turbine tank. The air volume on top of your turbine oil tank, or imagine a bearing housing in the fan, doesn't matter. You have some air inside your bearing housing or in contact with your oil. When the oil is agitated, it's going through a lubrication system, it's going through your pump, is returning. So the air is mixed with the oil. So now oil has an additive which is designed to this air which is trapped inside to come out faster. Means that it comes out, it should not be trapped inside. It is on top of the oil, and then that additive is attacking the air bubbles to be killing them faster. A stable foam is the problem. Little bit of foam which is not stable is not a problem. So a stable foam means that the anti-foam additive of your oil is consumed, and the stable foam means that you can always suck oil which is having air foam inside and then go through the bearing zones, high pressure zones, and then it can damage the bearing because you have air inside trapped. So there is a big risk that you have a stable foams. What I have done with the stable foams is that two things. Number one is that do some bleed and feed, like 5% to 10% remove, and then add the oil because you are refreshing the anti-foam additives of the oil, which are some polymers or sometimes some solid designed in the oil to be killing this stable foam. If the what are the reasons of foaming is the surface tension of your oil is changed, so it is keeping the air to be on top of the oil and it doesn't disappear. So to correct this, sometimes a bleed and feed is corrected, but sometimes a contamination has caused damages to the oil that the surface tension just by 5%, 10% of bleed and feed is doesn't solve. So my recommendation first is that check your design of your seals, of your lubrication systems, and normal big OEMs have considered that less interaction with air. No air is sucked in, too much of air sucking in causes more foaming issues. So seal issues, then pump seal issues, and then hatches and covers on top of the tanks. These are having problems that more air is coming in, then you have more foaming issues. The solutions for foaming issues is sometimes they add anti-foam additives, which I don't really like it, to any in-service oil. Adding a sort of chemical is not going to work. So adding the same oil is a solution for you, but the more problems of the foaming I have seen in the industry, they are mechanical related problems, which you need to find where is the sucking of the air is happening more than usual in your system.
Okay, thank you.
I will just have some water and stuff. I am here up to 11 just for the question and answer. Then 11 I will start again, so you are free to go and come up to half an hour. I am available for question and answer. Okay, I'm sitting here.
Uh, good morning, sir.
Good
Speaking.
morning, sir. Shiva, please
And
go.
can you tell me the please regarding the particles that counts if you minimize in for the turbine oil that will help for the OPU system, and how is this between related to each other?
OPU system, what was that one? I didn't get it, the question. Sorry, again. What was that system you said?
Processing units, that's for turbine bearing.
Ah, okay, okay. I got you. So, first of all, new turbine oil comes to site. Warranty case is there, and the turbine OEM is there. He's sometimes pushing, like Baker Hughes, I have seen some GE people, some Siemens people, they push that. What is the cleanliness of the oil that you are filling in inside your turbine oil tank? Number one. So they pre-filter the turbine oil before filling in using a filtration skid or using a flushing skid. You can pre-filter the oil before filling in, or test your oil, new oil, turbine oil, which is delivered on site. What is the existing ISO particle count that you are delivering? So when you deliver and you fill in, during filling in till the turbine starts, there is also some contaminant going in. Normally, what I do after a startup of a turbine, within a week, I take a sample. And this is my baseline of the ISO cleanliness of the turbine oil. So that sample which I take baseline is for everything, but I mean now we are talking on the particle count. So you know what cleanliness you started your oil. For example, let's say 16, 14, whatever, very clean oils. I have seen 18, 16, 11 as well being delivered as new oils. So then no, it should not increase than the target. The target is 18, 16 something. When you have increased one number, two number, then you will have problems with your bearings because this is a lube oil for the bearing. So there will be scratches, there will be wear happening in your bearing. If your bearing is going to work like 10 years without any problem with clean oil, then you will have problems in your bearing much earlier. Then you have these contaminants and these particles. So I would consider number one solution for removing particle is your inline filters of your turbine. So check if this turbine has given a 1 micron, 3 micron, 5 micron, and what beta ratio. Beta ratio is the capturing efficiency. Beta 4000 is made nowadays. So 4000 particles come in, then 3999 particles is being removed. So first increase the efficiency of the inline filters of the turbine oil. Sorry, turbine oil system, lubrication system. Then, if the inline filters are not capable of delivering the results because more contaminant is coming in through the seals, where components are made from the bearings and the valves and the system, it's coming more, then you need to add kidney loop filtration. Kidney loop filtration means external filtration to the tank. So you take the oil from the tank and put it back. So you use an external filter with higher efficiency and higher capacity than the inline filters of your turbine oil to achieve the ISO particle counts needed. I would say that for any turbine oil, not above 18, 16, 13 here we mentioned, yeah? And, the target is 18, 16, 13 maximum. So Chandra has a question. Yeah, the emulsibility can be fixed with ion exchange resin-based filtration. We fix the emulsibility by removing polar media, so the emulsibility fixes. Only filtration technique that fixes the emulsibility is ion exchange resin-based filtration. No other technique can fix the emulsibility issue. We don't allow emulsions to form, which I will be explaining in the afternoon. I hope I answered Shiva your question. I hope it was clear.
So regarding the varnish, can it be observed on the roller or the spheric bearing like from LM 2500, or
Yes.
or is it a characteristic of the plain bearing?
No, no, it can happen in any sort of bearing. Let me just show it to you. Some photos of rolling bearings as well, because rolling bearings have less clearance than journal bearings. Then you have yeah, then you have higher chance of varnishing in those bearings. In LM series, in these aeroderivative turbines, you have these rolling bearings, and then you have a higher chance of, I mean, I have today afternoon, let me just open it. The photos I have, because we are focused more on journal bearing, but the rolling bearings and gears, they have less clearance. So I will show it to you some rolling bearing photos as well. I have collected. Let me just find them now. That it was an afternoon session. In LM series, you have higher temperatures, higher speeds, as well as less clearances in rolling bearings. So
Yes.
you will have more problems in varnish there. Journal
Okay,
bearings,
thank you.
they suffer less than rolling bearings, to be honest. They take more time to be showing vibration and temperature peaks.
Yeah, yeah. Thank you.
To 20 send their emails and then 50 attended. So I can say 25% they made it to happen in their weekend. It was a good one. The question was coming from Vitor. Vitor, I just found that photo I have. These are, let's say, let's go for journal bearings, but I have a rolling bearing photo, and let's come. Da, 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 da. Yeah, I think it's coming down there. Uh, yeah, not here. Sorry for that. So let me just. I put it in the article here in EPT website on that rolling bearing varnish. I have seen, yeah, this is the compressor which had this varnishing inside. I think you see this one, rolling bearing. Because rolling bearings, many people they feel varnish is only for journal bearing, but it happens in rolling bearings much more. It kills the oil much more because higher pressures happens, gigapascals happens over there, and the shear forces on the oil as well is much more on the rolling element bearings rather than journal bearings.
Hello, Hashar. First of all,
Hello.
thanks for this session. Let me share my experience, and it also connects with the question as well. We had reduction gearboxes on cooling towers. There were different models. So some of them were single reduction and some of them were double reduction. And we were using same oil for both set of gearboxes. Some years back, we started having a foaming issue on single reduction gearboxes. So those were manufactured by Amarillo. We tried to change the oil. Initially, we thought that might be the oil is faulty, and we changed it with new oil, and the issue was still there. Then we connected and we took up the case with the manufacturer, and they recommended us to use. Initially, we were using EP oil on all gearboxes. Then they recommended us to use a non-EP oil. So we switched to non-EP oil of the same manufacturer, and to my surprise and my expectation, the problem of foaming disappeared. So although I couldn't correlate it with why the issue was with EP oil, and when we switched to a non-EP oil, the problem disappeared. But this is the fact. Can you guide me on this?
Yeah, I would say that let's focus not on the additive, EP additive, focus on the foam, anti-foam additive presence. If I was you that time, because anti-foams, they are in two forms they can be formulated. One is a form of solid, which is silicone-based solid additives they formulate some oil manufacturers. So they are submicron additives, anti-foam additives on the oil, which are scattered. And then there is a high chance of these anti-foam additives. You know how they work? They go on the bubble, air bubble, and they make it the surface tension. They change it so the bubble explodes faster, so it doesn't make a stable foam. And then the new way of making anti-foam additives is the making a polymer which is dissolved in the oil. So I would say that the oil which you changed on the new oil you changed, the first one had maybe a solid anti-foam additive which was being captured by the filtration, or it was dropping out, it was not working. And then new formulation had the polymer additive, which is more effective in my point of view than the old generation of the solid anti-foam additives. What I would be having a proper focus on the anti-foam package and the anti-foam foaming testing on the new oil, used oil, as well as the foam anti-foam package of these two formulation which has been delivered to you. There is no correlation with the anti-wear, the EP additive, to be honest.
Ah, okay, okay. So actually, the major difference between the oils were that one is EP and the other one is non-EP. So I naturally thought that might be
Different
it has something.
manufacturer, you said.
Yeah, yeah.
The
Okay.
formulation of additive package has changed as well if there is a different manufacturer of turbine, the gear oil.
Mhm.
So I would say they have a different concept of designing the anti-foam package. Because gears are really too much agitating the oil. So the anti-foam package is really important in gear oils. So don't focus on EP, brother. The new oil which you put in, it has a better anti-foam package. The additive was performing better. I'm thinking of EP additive is forming a layer on the gear surfaces is not really related to foaming issue. Foaming is more air coming in and how the anti-foam is really supporting it that a stable foam doesn't form. So nothing you change with the gearbox, sealing was the same, gearbox was the same, or you change the oil only. So by the changing of the oil, the issue disappeared. Then the only point comes into mind is that the anti-foam package of the new oil introduced is performing better. There was a question by Suleiman in our sorry, Shahid was asking about for a newbie the oil analysis what study material. So I really recommend level one material from Noria Corporation. That's a good one to start. And then in our synthesis gas turbine, lube oil. Yeah, I have done this in Nigeria in Indora. The lube oil sample is taken only from the filter on the return line before entering the tank. Is it advisable to create sample point on the return line to actually know the condition of each bearing? Yeah, very good, Suleiman. Yeah, before the filter element is always recommended. If you cannot modify the line after the bearing, at least the oil sample should be taken before the filter, not after the filter element. So you can capture the wear element before the filter removes them. Yeah, you are right. Use cooling tower. Yeah, we discussed. We have a schedule for oil and oil change. If you can change this Amarillo gearbox oil analysis reports before and after, I would like to know that if silicone is available in the new oil test. If silicone is formulated in new oil, you see it in elemental analysis, then it's a solid form. Then if silicone is not available in the new oil, then it is the polymer design inside, and then yeah, I think I need to have a new oil and used oil analysis reports of these gearboxes to have a better understanding what's going on. Because the contamination sometimes causes the foaming issues happen. So I need to see the level of contamination in this. But if you say a new oil change and no foaming has happened, then I think it's a formulation related. If you please, can you advise best practice for collecting the oil sample from Turbomachinery? Turbomachinery, normally the oil sample collection location is decided by the OEM. Some OEMs, they put a valve before the filter element, the return line filter from the tank, from the bearings. There is a main header. The oil collected from all the bearings coming to the main header before reaching the tank. There is a filter element on top of the tank, and then before that they put a valve for taking samples before it reaches to the tank. Some of the OEMs, they don't design this, so there is a place that on top of the tank to put the hose inside and take from the breather element. But some turbo machinery, they don't have breather element. They have a vacuum on top of their tank. So for sure, if you have such a situation on the return line, there should be a valve for taking the sample. And if this is not designed, then the only chance remains is from the drain of the tank, but that's not a good sample at all, or from the kidney loop filtration. If you are connecting a kidney loop filtration to your turbine oil tank, then before reaching the filter, then you can use your kidney loop filtration for taking a sample. But normally the best sample is before it reaches the tank on the return line. That's the best. So Ghulam Jailani from Dubai Gas. So let's go. Vitor and Fashion. Varnish is more detrimental for rolling anywhere as it forms layer. More localized on the spot, correct. Every rolling element bearing touching the raceway, it causes heat and pressure changes. I've experienced on auxiliary bearing failures, speed pickup assembly drive of Siemens AO GT. Wow, very nice experience here. Bigger size rolling element will sustain more time in such service prior to failure. Yeah, the smaller the bearing, the smaller the clearance, so varnish can cause faster the problem, correct? Keep an eye on acid numbers, Khashoggi explained, as a precursor to varnish. Closely monitor bearing RTD and oil temperature. Very great experiences, Sherry. I have seen journal bearing easily surviving till plant shutdown. Not rolling element bearing. Yeah, correct. But I have seen also journal bearings having in 2, 3 years time vibration issues coming and failures. But as you are rightly said, rolling element bearings, they're much more sensitive to varnish. Great knowledge sharing, Mr. Ghulam. I'm really happy that you have joined this session. So yeah, I think I will jump to just shortly, and then I come back in 15 minutes. I give you time now, 10:46 Oman time, 11 rightly. I start that oil analysis workshop. Okay, see you guys. I recommend don't disconnect the meeting. I just come back. I just keep it on running. Thank you. If everybody is okay, I can start earlier so they can finish earlier as well. If you're okay, I start now. Do you hear me? Can you hear me now? Okay, very good. So let me start. These are some oil analysis reports from my region that I have received, and then I will go with. First of all, let me start with oil analysis reports of some of the attendees, and then I come to some of my recent cases that I have been dealing with. Okay, it's the first time I'm opening some of these because it was sent to me for this course, so I will just open it in front of you. This is coming from one of the members of the group, so let us do it together. The report date is from sample received on 2024 October. So let's see, this lab is giving T40 turbine lube oil. Running hours is 15,000 hours, almost 2 years, and the oil is clear. Like, we don't have any baseline, so we have just one report that we are looking at. So the color ASTM, you know what I do, ASTM 1500. So let's just show it to you. What I need to ASTM. As per the recommendations of ASTM, below 3 is always good, but above 3 oil problems as a started. So this is the color scale to measure the color of any turbine oil. So here you see that AS is 2, so it's okay. And then viscosity is 46. Not much of the decrease or increase, everything is fine. Look at the acid number. The issue we have is 664 here measured, so very good potentiometric method, but this IP1, have they modified it or not? I don't know what the IP1 means, but okay, they are doing it potentiometric, and then it is 0.07. It's almost like a new oil acid number, so not much problem with acid number. Water content 20 ppm, everything is okay. Here they mentioned 956304 cracker line, which test method they are doing. I don't like it this way of writing. 6304 is the Carl Fisher, so I mean, which one they are doing, I'm not sure. FTIR, no oxidation, nothing. And then let's go elemental analysis. Phosphorus 30 ppm from the anti-wear package, I mean the additive. And then here you see no problem with the foaming. For corrosion, air release is okay, and RPVT 610. So RPVT 610, how much is the new oil RPVT? We should have always, everything is fine with this test, except here I see big, I mean, it has dropped a lot. What was the new oil RPVT? Without mentioning the RPVT of new oil and the percentage in decrease, we cannot. We just know that this oil is worked 15,000 hours. Within 15,000 hours, how much RPVT has dropped? It's a little bit concerning. Launch potential, no problem. Delta E 1.3, very good. No problem. Particle count 1614.8, very nice. So I think consider this one very good. Everything is fine except it's, I don't know how much RPVT of the new oil it was. They are not mentioning make and model rock fin, maybe it is a turbine, but the oil is not mentioned here, so that I can have an estimate. T46 maybe Shell or local made oil, I'm not sure, but the RPVT value is not matching with everything is fine in this oil analysis report. Looks like a very new condition, no particles, acid is okay, but why this big drop of RPVT has happened? Or the new oil RPVT was 800 minutes, I'm not sure. Let me read the comment. As is a reliable test. If I had to choose, shouldn't we consider ruler over RPVT? You should. RPVT is reliable, but I told you, dear, RPVT is not for condition monitoring. RPVT shows always high values when the additive level is there above 50%. You have lost 50% of your antioxidant, then RPVT starts dropping. So always for ruler is need to be done for the condition monitoring routine. Once a year, do RPVT. RPVT is not a good test for condition monitoring. So here, ruler test is missing. We don't see the additive level. We see only um, RPVOT value. So I would consider that this oil doesn't have any problem, but I am missing the target values for the new oil is here missing. Let's go to the next oil analysis report I received from this gentleman. I received him from Seal Oil as well. Let's see Seal Oil. Here, they have not done the old test. Seal Oil, they are doing water content. Same oil, but they are doing just particles. So here you see that the particle is much bigger, 2017-8. I have seen a lot in oil and gas industry that seal oil systems are considered to be not really applying a lot of maintenance on them. You see that the varnish potential is not done, acid number is not done. I know I'm not really sure that the seal is becoming the number one failure of turbomachinery, and then the oil analysis is missing a lot of points. Particle point of view, the seal, mechanical seals, wet seals, they have very tight tolerances. Why accepting a 2017-8? It's disaster. Maybe these seal companies they wanted to sell more seals. The John Crane distributor in Oman is my distributor. I am really challenging John Crane people. I have seen a lot of seal people, but the focus has been more on the bearing rather than the seal. And we need to really apply the same routine of analysis as well as the maintenance on the seal oils, wet seals as well. This is having a very high particle count, but not a complete testing. Let's go for another oil analysis test I received from, these are from the members of the group. So the control oil tank, steam turbine, mobile pyrotech. This is the HFT46. It's a synthetic oil. So let's analyze it together. So the dates are January 2024, April, July, October, and then November. So we have 5 results of 1 year. Let's continue together. So water content 1000 ppm. This oil can hold a lot of water inside. So this HFT46. So I should approve. So some people are coming in. Okay. Sorry. Okay. I fixed it now. Let's go further analysis video on this one. Okay. So we don't know the tank volume. I don't want to read these comments, but later we can comment. So let's normally hydraulic tanks are a small volume, but let us go for analysis. Water content has been 1000, 1200, then became below 10. So maybe they replaced the oil here. And then again going to 1000 ppm. So this seems that there's a lot of water coming in here. And this control system is in a wet area. Total acid number 0.23. So total acid number of a new oil, I don't know here. So 0.23, 0.31, 0.37, and 0.44. If we consider the acid number of this oil is, let's say, 0.15 or 0.1, for example, And then because it's acidic, these synthetics are acidic, so you are having it, let's say, double the acid number in just 1 year. It shows to me that the filtration done on this oil is not removing acid at all. So maybe they are just managing the chemistry just by adding the oil. And so filtration is focused mostly on particles. So NAS values are given 12, very high value from 7 to 12. So maybe seals are having issues, and then filtration is not enough adequate here. You have a big amount of particles added. So they replaced the oil here, it seems, but it didn't work. Very high particle count. And then they have seen some fuel dilution there. This is done for engine oils normally. I don't know why they are doing it here, but there's a high amount of fuel dilution here. Fuel is maybe by mistake it has been done in the maintenance, or why it is coming into this hydraulic system. Not sure. I need to check with the person who sent it to me. Then you see that on the FTIR, this is FTIR results. Water is very shown here. They had high water content. And shown here. Sorry, the question came in. How would you new oil filters improve time? What do you mean new oil filters? No, brother, the ion exchange resin-based filtration, which I will be discussing, removes acid only. No other filtration removes acid. I will be discussing on filtration. Just give me some time. Mechanical filters remove solid only. You cannot remove acid with them. There are acid filters as well. There are chemicals. I think I need to mute everybody now. Can you mute yourself? Okay, let me do it. I will mute everybody. Muting options, and then I will mute everybody, then I will mute you. I will unmute you later. Okay, so let's go further on elemental analysis. So this is the reason it was phosphate ester. So you see a lot of phosphorus here. And then the breakdown of this causes also the bale. This is a phosphate ester, I believe. So this is high amount of phosphorus because it's full of this phosphorus when it is designed. NPC very low. I hope that they know how to do NPC testing. Please review with your lab that this oil, the NPC test should be modified for it. The normal patch of NPC test designed for mineral oil doesn't work with this. So it should be a little bit modified. So I would say that on this hydraulic oil, water removal is the main problem that they should do. Water content is too high. And then the acid filters need to be designed. They're very, very high acid numbers. Let me go. In another case I received, this is another type of hydraulic oil, same plant. We can have a good comparison of each other, same type of oil. Control oil tank. They have another type of oil here. The other one was mobile. This is another oil. So let's go. Acid number 0.14 and the 0.07 here. So it was a dropping, increasing, dropping. So what's happening with the acid number? I need to see that they are adding oil or not. And then you see that the cleanliness is very good. Last, they are maintaining 76. They are doing a good job on filtration here. So there is not much problems with the particles here. And elemental analysis, no problem. NPC, you see NPC 33 here. And then the ruler is showing that the additives has been consumed. You see the amine and phenol. Now one of them, phenol, is 20. Amine is dropping as well. So the corresponding together NPC and additives are showing that there is a varnishing problem here. You see that the particles were removed properly. They were removing the particles properly. Now it's 6. And with this 6 value still, they have a varnishing issue. So varnish is not related really to the mechanical filtration that we are doing. So this is a very good example of chemistry dictates over the oil failure. A great case on this one. The main oil tank. So let's go. It seems that this is the lube oil tank. The other two were hydraulic. And let's analyze your acid number. They had an increase of 0.21. It's huge, 4 times more. how they gone back, how they fixed it. Sure, now they are running with 0.06, which is very good. And then NAS overtime 8 is a little bit high for this kind of application, but ISO particle count need to be reported with ISO 4406, please. NAS is outdated. And then let's go for elemental analysis, phosphorus fixed, no problem, no other elements. And ruler, you see here 36, 42 all over the time. They have lost additives, and then MPC 26 also. So it seems they have varnishing problem. So tell me, sorry dear, what was the question here? What difference does MPC tell us? Yeah, MPC above 10, if your oil is saturated, it's varnishing, it's depositing. And here they have an MPC of 26, they have experience 32. So there is a chance of varnishing. They have a high varnish potential. Sometimes you don't see varnish, but there is a risk, big risk. MPC should be near zero. Then MPC near zero means no risk of varnishing. So MPC varnish potential is high on both cases. They have problems. Intertech, very good global lab. I really like what they do. So let's go for another case I received. Go with global. They had a lot of fines. This is coming from Pakistan to me. So let's just analyze it. NAS 7. I would say again go for ISO 4406 on NAS 7 is good one. Particles are okay. Acid number 0.3. This is huge acid number. Max, no, not acceptable. They are running 0.04. But who has written maximum 0.3 on it? This is wrong limits. No. You can never allow an acid number of 0.3 in a turbine. You know the no acid number of a new oil, maximum 2 times acid number of a new oil. This is not acceptable. Like this to write the limits. So acid number 0.04, it's okay. Water content 26 ppm, no problem. Here they write limit 116 for sure. But what does it mean 116 water content maximum? No. If it is a mineral oil, then 200 ppm. I don't know where they bring this maximum, min and max. Their targets, or sorry, their limits seems a problem. Then appearance, no problem. Water separability, so they have emulsion forming. What is the way of reporting here? I should be seeing 3 numbers and then the time. I don't know why I see like this way of reporting. So they have the oil emulsion, nothing. Should be different way of reporting the emulsibility. This is a little bit problem for me to read it. Yeah, MPC is not tested. Ruler is not tested. Elemental analysis is not done. Let's go to unit 2. Then mass is 7. Picard the one was 6. I think acid number 0.02. They have very low acid numbers reported here. I don't know the acid number of a new oil turbine oil. Normally, I have seen 0.06, 0.07. I am a little bit. I don't know why they bring this much of very low acid number reported, because it has anti-wear additives and some additives which are a little bit acidic. The new oil. I know these results are a little bit. I really want to retest them and to see. I have never seen in the last 12 years 0.02 or acid number of a new oil, or even used oil. I mean, this is very low value. Then the water content, Carl Fisher 36, very no problem. I don't really like the way of the reporting on demulsibility. And MPC and ruler is not there. Let me go to my own cases. So this is coming from a famous lubricant manufacturer. Yeah, I've been testing this lubricant, so it's a turbine oil. Let's go together. So color brown, light brown. We should report it ASTM 1500 with the levels as we discussed and show here. Writing like this is not good. We should show the color scale like this one, not this way. This is a very global lubricant manufacturer, by the way, doing it. To be honest, he was sitting with me in the same room in the September 5 You know, I worked with the international companies myself before. It doesn't mean that they are experts in everything. So they need to really learn sometimes to improve themselves. Their focus is more selling oils rather than testing the oil, to be honest. Water content, you see that all over time has been low, no problem. Gas turbines, they less water problems. Acid number 0.09, it increased to 0.16 and 0.11 now. So consider that the new oil acid number doubling is a problem. Problem starts. And then spectrometry, normally let's focus on the additives. So phosphorus 20 and not much loss, not much other. You know, I like that they have put some limits for the calcium and the silicone for the also contaminants. And then I was shocked when I went through this report and then I showed them there is no MPC, no ruler, nothing. And then they say, oh, we never have a problem. Every 5, 6 years, we change the oil. It's a global lubricant manufacturer, by the way, testing. And let's go for second one. You know, very famous lab in UAE testing this one. So let's go for this is called a gas turbine lube oil. Color is 6. You see, this is very dark fluid. It's a problem. And then water content, no issues. Acid number, I don't like it that they are doing 974, but it's okay. Why they write the maximum 0.5? Where they bring it? I mean, this is not the way they should be writing the limit. And then 0.43, it's already the acid number. It's huge acid number for turbine oil. It's 5 times more or even more than that of a new oil. This is huge acid number. And the flag of 0.5, no. This is wrong. This is not as per D437 recommendations. This is huge problem. So no water problem. MPC, the way they are putting limits is the old way of the standard, and since they have copy pasted it from the EPT materials. So they have a problem with MPC 31. It's a huge number, big problem. RPVT minimum 25% for fresh oil, but they don't mention the fresh oil how much it is. MPC is high, acid number is high, but the RPVT is very high, 1,396. You know, remember the repeatability and reproducibility issue of RPVT. Sometimes the RPVT values are reported even higher than the oil manufacturer itself. So it's a very, very high RPVT value reported. I would say that this is not a very good test for condition monitoring purpose. Then let's go. No problem with air release and foaming. And then let's come to particle count. We see that huge particle count, 23, 20, 14. And their target is 19, 17, 14. Where they bring the target, I don't know. It should be 18 something. But 23, this is like a gearbox in the cement plant, not a turbine. This is a big problem. A lot of particles, high acid numbers, and high MPC. This is very fast failure can come. And the phosphorus level is also very high. I don't know if it's EP additivated gear turbine oil. If not, then there is a high chance of mixing with different oils of hydraulic oils or gear oils outside. This is a big value for phosphorus on a turbine oil. They didn't mention to me that uh, they have which type of oil, but this oil has a lot of problems. Okay, there is already a VRU varnish removal unit on site working with this condition. They buy a lot of varnish removal units and they cannot deliver the results. So can you elaborate more on RPVT is not a good test for condition monitoring? Yeah, RPVT is breaking down the total oil. Again, if you have 50% above additive level, additive means antioxidants. Antioxidant is breaking down is controlling the oxidation material. How the RPVT test is ending, that the pressure is changing due to the breakdown of the oil. So the old antioxidant should break down, then the RPVT test finishes. So below 50%, when the oil is breaking down, below 50% additive level, you have a very fast breakdown of the oil in the RPVT test. But above 50% RPVT is not dropping much. So my point is that the ruler test is showing the antioxidant additive exactly, but RPVT is breaking down the total oil. So we should use the ruler rather than RPVT for condition monitoring. RPVT once a year or at the end of the life of the oil to make sure that the life is ended is not at all a good test for routine analysis. I would say even once a year is a waste of time. If you have below 50% remaining additives, then you do RPBOT only. So let's go for the another case. I want to open another one. So this is coming from centrifugal compressor. The date of reports are 2024 and ISO 46. It's a propane compressor in oil and gas industry. So let's read together. The results are from April, May, June, July, and August. We have around 5 sets of monthly has been tested. And the appearance is level 1.5 on the color 1.5 and then darkened, and the last one is a little bit better. So it has been darkening all over the time in the year. And then water content, no problem. Total acid number has 8.11 and decreasing all over time. They have maintained it very properly. Not sure with the bleed and feed or top up or how they have maintained it, but very good. What I like here is that this lab is putting the upper limits, the caution action. But this is, to be honest, very high values. This should be done as per the D4378 and as per the new oil acid number, not just putting like this one. There's a question came in, let me answer. Yeah, Ali, you can send it same in the WhatsApp. Sorry, in this chat, if you can send it in Teams, I will open it up now. Or you email me as you wish. Just let me know when you send it. Then let's continue. Water content, no problem here. Total acid number, point out, we discussed it. Isoparticle count was 16, 13, 10. That decreased it, very good filtration, and increased again. 3-digit increased here. Big number, so it was 300 particles total, 2000 particles reached. Maybe they did some maintenance or some failure happened, and then it is controlled. But this change happened, I need to investigate this change, which I flagged to them. And then let's go for, there is no MPC, no, unfortunately, no ruler, not much on the chemistry side. Such critical compressors, unfortunately, in the industry. Sent you an email, Ali. Yeah, sure. Let me just open my email and then I will do your case right away and then I do other things. Okay, Ali, let's do it together. So this is I'll sending to you. So sampling date is September. So first one was February, and then Carl Fisher has been done. A little bit high for this is which equipment? Is it gas turbine? Seems gas turbine, yeah. Ali, can you write it down? Okay. 100 ppm, yeah, a little bit. I'm not sure. I would say that is it this tank? Tank has a breather element or tank has a vacuum? Tank, oil tank has a vacuum or it has a breather element. No vacuum. So that's the reason they may be from ambient air coming. And then a little bit high value for the case of gas turbine. And then phosphorus 7 now 14. It has, this is a new oil, February, or this is a used oil? Ali, you can give me the life of the oil. Working time 230,000 hour, mileage of oil 48,000, 1,000. So it was replaced after February when it was replaced, just to know, to have a figure of this February to September, what has been done. You can write down for me. Suleiman, I will read it later, brother. So when it was changed, Ali, the oil? Now new oil is filled. Okay, nice. So let's consider that this is the used oil in the past and the new oil is in the service now. So acid index. This is not right way of reporting acid number, no acid index. But which test acid number they are doing? Carl Fisher is mentioned here, but they should mention in your oil analysis report which test method they are doing. So 0.14 acid number is increased, 0.1 it was before. So acid number for new oil, please add it, Ali, here. So I know this Total has making in different regions, different acid numbers, different packages. Same Total, Presley, we have different acid numbers of coming 0.0, 0.05 to 0. I mean 0.1 I have seen as well. So please make sure what acid number is the new oil acid number. 0.14 for the newly replaced oil is a problem. Maybe it was old varnish in the system, or the new oil acid number is already high. You have a very high acid number for the new oil replaced. Okay. So phosphorus level is 14. I need to see the new oil tested. So this is a little bit used oil, no? September, how long it has used, Ali? You write down for me. Sorry, guys, I'm talking to Ali, Suleiman, and Chana. I will read 2 months. I will read your comments later on, okay? So let's come here. So phosphate, to be honest with you, before coming to 2 months ago, you should put a new oil also baseline before putting it in. So I need to know phosphorus level for a new oil. And okay, the rest is okay. This way of reporting less than 10 ppm, less than this, I don't really like it. They should put the number. So your testing, let's continue. Which one was it? Now I went to another turbine, or why the so many pages are there? So I have 7 pages. This is same turbine, TK, or why 7 pages, Ali? You can tell me this is the same report for different turbines. Different turbine, okay. So what is missing in the first one? MPC is not included, ruler is not included, and yeah, MPC and ruler is the main, not included. And I am having a doubt of 0.14 for a new oil change, because maybe old acid and varnish came from the old oil, from dirty system. It was not properly cleaned, or varnish removal was not done properly. Let's go for the other turbine. This one has a better acid number, but I don't know which method they are doing. 0.08 before. And this new turbine I am analyzing, Ali, can you tell me when you change this oil as well? It's mentioned 80,000 hour, now 84,000 hours. So this one was not changed. This is still working, correct? This is old oil. Okay, good. So let's analyze good one. So this was 0.08 going to 0.11. So there is a normal increase, no problem here. Particle count is 21, 17, 10. Previous one, particle count was not reported. I didn't see particle count on this one. Okay, anyhow, not a complete test package. And then this one is reported 21, 17, 10, not acceptable at all for turbomachinery. Very high particle count. Filters on site are not doing the good job. Phosphorus has been lost. Maybe a bleed and feed is required to bring the additives a little bit higher. But before bleed and feed, please do the proper varnish removal. Here also no MPC, no ruler. Ali, the test package is missing a lot of things. I mean, this cannot be doing a proper analysis. It's a very minimal amount of tests they are doing. So that's the number. See, this one is 0.13. But how they flag it green when it's 0.04? It's like 3 times more. Then I say, not a very good oil analysis report, brother. So let me continue with my cases. I think your case as well. Then MPC should be at least there, the ruler should be there. Sure, Mr. Ghulam, I come to that. Let me just do it my own cases. I will come to your case as well. So now this case is from UAE. So let's go for RPVOT is mentioned 127. Mileage of the oil is not mentioned here, just one result we have. So 127 of RPVOT. It's a very low value. How much is the where is RPVOT? Sorry. Sorry, 1,700. By mistake I read it. So they mentioned more than 500 minutes. Not a good one. They should mention exactly what is the 225 minute, 25% of the new oil RPVOT value. MPC is 12, not a big problem. Problem has started, but not a big issue here. And then acid number 974 has been done, 0.12. They mentioned less than 1. Less than 1 is wrong. Maybe they mentioned less than less than 1 acid number. This is completely wrong. And the ISO particle count 19, 17, 13, not very bad, but it could be improved. since this oil has started having problem, but very, very low. I have never seen such a large RPV, to be honest. 1,700 minutes. I mean, to be honest, this is they are really making turbine oil manufacturer even happier to make to report such a high RPVT value. Then let's go. This is a compressor, turbine-driven compressor in a steel company in UAE. So you see 1,800 minutes even mentioned here. Same kind of company. So yeah, MPC 7.5, less problems. ISO 191712. Ruler is not done. So Mr. Ghulam, let's go to your chats. So let me read all the comments here. So Danish, this I replied. In our facility, we have a spectro at the mini lab. We don't test for MPC. We don't have an issue of varnish, but there are process fluid mixing with oil and we foaming like on the oil. Is the MPC test? Yeah, sure. MPC is a must on turbine. You should be doing it. MPC and ruler. So I found the emulsibility issue with low water content in lube oil turbine with 8,000. What causes the issue? So it's mostly MPC varnish is causing the emulsibility issue. So you need to remove varnish with ion exchange resin, then the emulsibility fixes. I will discuss with this one about the filtration part. Sample location, should oil report mention sample location? To be honest with you, they don't mention it really. It should be mentioned in a proper CMMS. Even the sampling process should be there. Sampling procedure, where to take, how much to take. It should be part of the SOP for the maintenance team to where to take the sample, how much to take, and the sample bottle. It should be non-transparent for turbine oil. When the sample bottle is transparent, when you keep it on your desk, it goes dark and MPC goes high. It's a fake false negative. So Mr. Ghulam, I come to your email now. Let me just open it. Mobile jet is a polyester, so let's go. Jet oil is polyester, so it's a very critical oil. So let's read together. So we have April, July, November, and then we have end of November. A couple of results. So let's see. When I ask question, please let me know. But I read it for the moment, then I ask questions. So I don't see any equipment live or oil live for the moment now. We analyze. So appearance, it was little dark and then more dark, very much dark, and then not reported anymore in the last two. Viscosity was, is it 32? So it's 26 is too low now. Is it 32, sir? I believe, yeah, the viscosity of this one. So 3.2 is the maximum plus 10%. Let me just focus on viscosity. Is it 32, Mr. Ghulam? Just let me come to the chat. Now, Ali, don't do it with turbine manufacturer, oil manufacturer. Total is selling you oil and they are doing minimum tests. And do it in a proper lab in the area you have. Maybe Mohammed Nasir, which is our partner in Pakistan, can guide you through the even send from to Dubai the samples to do it in Intertech and so on. It's worth to do it if in Pakistan you don't have. ISO no 32 is increased value. So how much is Mr. Ghulam this viscosity of this mobile jet oil 2? Viscosity of is it less than 32 or when new oil I'm talking? The range is here mentioned 22 to 29. But the limit I'm not asking is it I think it's less than 32 when you buy it, yeah? The lower range. Okay, it's not 32 even. I got you. So it went up 33. It has an increase of viscosity. Maybe it was due to very, very, very dark. It was having a very high breakdown, maybe high acid as well. Let me just check. You had a very dramatic increase of viscosity in these two results, and then it dropped. So viscosity issue shows that a very huge breakdown has happened over there. So let me focus on acid number. These oils are having very high acid numbers where they are acidic on their nature. So it was a 0.1, 0.5. I don't have acid number of a new oil. If you have it, Mr. Ghulam, let me know, then I can do a proper analysis. Here they mention limit less than 1, but this is not a new oil acid number. I need the acid number of new oil. Maybe 0.2 or 0.25 something is the new oil acid number. So you have a 0.5, then you go 1.15, wow. And then 1.5, wow. 2.28, and now a 0.5 back. So you don't tell me now that you have replaced the oil in these 2 months, but the seems that the maintenance on this oils is not removing acid at all. There's a huge amount of acid generated. When these oils, ester-based oils, they are a little bit on stress, they make generate very, very high acid numbers. EPT experience is on ester-based fluid removing with the ion exchange resin we have. So this is huge acid numbers. Then this is 974. Can you please shift it to 664? This is not a regular, Mr. Ghulam. This is not the right test for this kind of. I understand this is a low amount of oil, but let me read it and then I can do diagnose better. We did 5 grams makeup, bleed and feed. How much is the total amount of tank in this case? What's the amount of oil, total oil tank volume? 92 gallons. So in liter, it will be, sorry, a gallon, I don't, by heart, I don't remember. So 5 gram, 1000 liter was done bleed and feed, and then 350 liter tank. So 5 drums, 210 each. 5 drum, 210 each means 1000 liter. Then total capacity is 350. I don't understand, sir. Sorry. You said bleed and feed was done 5 drums, which is 1000 liter, yeah? But how much is the total capacity of this tank? $350. Okay. Okay. So let me go back. Now, yeah, let's analyze together. So let's see. Do you know acid number of a new oil? It's not showing here. Limit, I'm not looking for intertechnical results. Acid number of a new oil, you know here? So column, acid number of a new oil. No need to check report where. Okay, okay. So you don't have it. خلاص. So 0.5, 1.5, this is a huge increase of acid numbers. You know, no, I recommend using this ASTM EA323. Let me just show it too. ASTM EA323 for such oils. This is the one. Phosphate ester based fluids, and then the numbers coming out of this standard, you have it here. So these are the numbers you should follow, that the limits are, the acid number is a 0.1, MPC 20, and yeah. So let me just analyze. So acid number, I don't know, we need to maintain it as acid number of a new oil, or like maximum 2 times more. It's a huge acid numbers here. So varnishing index, MPC 70, 50, oh wow. This oil really needs a chemistry solution. Just by bleed and feed, you cannot solve it. I mean, we need acid filter over there. And no reference of ruler, okay. And then, yeah, it's higher dense than the water comes on top of these oils. And then foaming, only particle count. So let's go 18, 16, 13, 17, 15, and the last two has not been done. Okay. Yeah, polyester it is. Yeah, Mr. Ghulam, I really recommend it on this system to be having a chemistry solution, yeah, like EPT system, because the system you have is not removing acid and varnish. They're both there is huge issues here. You know, I am doing in Oman a project in Barka in power plant. The acid number of a 0.4 in 1 year, they changed every year. This is a 2 drum of oil inside only, and causing this hydraulic system to suffer a lot. They have this synthetic oils. They bought $130,000 system from EPTs. I will share with you what kind of system you need for managing this kind of oils. So let me just go a little bit. I did Mr. Ghulam oil analysis as well. But I need a sample from this case, if you can give us a sample in Dubai to come to our lab, sir. And then I want to give you some oil analysis reports from my side on the like different type of oils. Excel reports, one factor makes such a difference, not operating your filter scheme. Oh, okay. You remove the filtration skid and then this problem started? You mean Europa filter is purchased by SKF now. They were using deep filter element, deep filter media, cellulose media. I will analyze Europa filters as well today in just after some time. The point is that that's paper-based filters. They're deep media. They remove the solid varnish very well. They are polar. They can remove a little bit of water and a little bit of varnish as well. But I mean, without filter going such high values, I would recommend that checking the system for mechanical problems as well as hot spot issues are happening, filter sparking, because this is a very, very critical. It's not just that you remove this Europa filter system and then the oil goes nasty with chemistry goes this way problem, but the new charge of oil has been mixed with the old varnish over there. It has been causing problem, and now your filtration is stopped. I need to discuss with you in the separate meeting because I need to have a sample in the EPT lab with the new oil and a used oil, 1 liter, so to have a proper analysis as well from our side. Yeah, but yeah, my understanding is that these oils, I have seen such high acid numbers, but why it was caused after removing your filtration? Uh, it need to be addressed because I feel that there is some mechanical problem as well combined with this killing the oil. So let me go back to my presentation. I will be continuing as per the timing. Let's say that the timing I had was that 11:30, 11 to 12:30. I do these oil analysis reports. The workshop, and I want to do now up to 12:30 continue the oil analysis. I want to give you oil analysis on different oil types from EPT side, and then 12:30 we go for the lunch break. So let me answer the question. We did a more on the oil sample butters for turbine oil. Yes, let me show it to you. They should be non-transparent sample butters. Aluminium material can be used, also plastics which are non-transparent. So sunlight should not go through the turbine oil sample when you take it from the turbine. I will show it to you a sample if I can find it here. Let me just show it to you. I hope I can get a photo here. I hope. Life of an oil sample. Yeah. Just a moment. Sorry for that. I show it to you that sample bottles we use in EPT, which are non-transparent sample bottles. Life of a sample bottle. This is better. Yeah, you have it here. I think so. Yeah, these sample bottles are like plastic, but brown color and like non-transparent we are using. Okay, so it should be light nozzle pass. The material and so on I can give you later, but the point is that it's compatible with your oil. If you're using synthetics, then be careful. Mineral oils, you can use most of the plastic bottles provided by the lab, but non-transparent is the key on the turbine oil testing. And then let me go for the analysis of the EPT, what we have done on the different types of oil. So these are some Chevron examples of the past that we have done on Chevron oils. So this is a GST32. So EPT system has been connected. We can reduce the acid number to 0.05. We put the target very clearly on our reports. Water is being a strong acid number can be also reported if it is present. So particle count target has been 16, 14, 10. It was 21, 18, 16, now reduced to 13, 10, 5. Very nice. MPC has had a very good decrease, going from 28 to 8. And then look at the ruler values. Their additive package is completely okay. So very nice. Oil analysis report is showing all the details. Let me go with some cases from like Shell oil, for example. So This case is GTG, Shell Turbo, this oil. Acid number target is 0.18. This is a new oil acid number. So this oil is having additives. So you see the new oil acid number is higher. So it was decreased, and then ISO code to 151410 delivered. MPC was 38.8, now is near zero, staying stable. Look at the patch photo. We put always the patch photo. It's very important to look at the patch as well, not only the MPC values. In APT, we report also patch weight, because if the solid is captured, that black carbon, it will be shown only patch weight, not only by the color. So we measure both. And then look at the additive level. It was 66, now it's 87, so it's amine based fluid. It's fine. So let me go for a kind of, let's say, Total and Mobile, some cases we have done. So Total Preslia, the same oil that Ali was showing. So acid number 0.07 for the new oil, Total Preslia 32. It was acid number of 0.44 this case, very nice case. And then they reduced it to 0.319. The MPC went from 50 to 8.1. Look at the patch color, and the particles were reduced a lot. This needs to another 2-3 months to run to correct the MP, the acid number. So it was just shown in like 2-3 years time how they just connected maybe recently in March 2019. They had huge problems, but the unit should be connected and running all over the time. So that this oil is completely dead as well, no phenol left. They should be having maybe they replaced after varnish removal, or they add bleed and feed. They add oil to increase the additive level. So let me go another example of like ExxonMobil oil. Something that we have done. Mobile DTE 0.2 is a target, is a new oil acid number. So acid has been fixed. So the particle count is very good. It was a 2016-23 they had. MPC has reduced near zero. And then additive level. Phenol has been lost secondary, but the still amine is there 66%. This oil has having high phosphorus level because of being highly additivated. So yeah, this oil can go many years more, but if you don't manage the chemistry very well, it will fail. So we are managing the oil properly. So I hope that I gave you flavor of oil analysis, clearly what you need to do and what you need to test. I want to just give I want to give you one question I have with everybody. I think we have around 38 members. If I talk now for 1 hour, everything will finish. 1 hour, 15 minutes, then question and answer. If I talk now and then we give break, you go lunch and then come back, it will be till afternoon continue. So what's your recommendation? We stick to the plan, we give a 1 hour break for lunch break, or I continue and we finish it, then we finish the meeting and then we go. What's your suggestion? I mean, we can vote. I mean, we can mention, or I will open the microphones now to a little bit brainstorm together. Let me just open I will open the microphones. Ali says better to have a lunch break. Continue and finish. Yeah, I can continue in 1 hour and then finish, or then we need to have a break in between. I don't know. Ali was the only person, so Matthew says continue. Let us have more votes. We are around 40 people, so then we can have a majority commenting, please. Can you chat? I prefer to continue and to finish it earlier than the plan, if it is fine with everybody. Because I am still feeling sick, and for me, talking 1 hour more is okay, but going for a break and coming back for me would be challenging. Is it okay that I continue with everybody? Thank you very much. So I continue for 1 hour more, and then I answer questions, and then we close it before 1 p.m. my time. Thank you, everybody. Thank you. You can go and bring your lunch and have one whilst I'm talking. Sorry for that. Thank you. So, okay, thanks for everybody helping me with this way. So let me continue. So now this is a case of on oil analysis, the results come. Either the oil is inside the specification or oil is outside of the specification. If it is inside the specification, then we need the proper maintenance solution or filtration to keep it in a spec. Or if it is out of a spec, any of those tests, then we need to find the right solution. How to correct the particles, how to correct the water, how to correct the varnish, and how to correct the acid. If it is too much out of a spec, there would be a lot of acid filters, a lot of filtration required. If it is beyond restoration, it's not economical. Sometimes we need to understand that is it economical to filter the oil and to maintain or to change it. But sometimes replacing the oils, the old varnish and old problems stay in the system, damages the new system as well. So we clean the surfaces of the machinery using the same oil with our technique. EPT technique uses the same oil which was generating the varnish and the issues. The best medium for cleaning the system is the same oil that was creating it without any use of like chemicals or flushing as such. I'm talking about normal filtration practice. So we need to consider how much the oil is out of spec and can be restored or not, or do we need to do a replacement or bleed and feed even at the end of filtration. So depending on the where we start, how much additive is remaining, what's the starting acid number, then we decided how we can do the job. So EPT Lab in Canada has made the this facility that we clean the oil with the same resin and same filter. We can tell you what to do. But this is a practical case of Oman that I have done. 4 turbo compressors, 4 centrifugal compressors, 2022 results, 2023 results are being compared. Same shell oil, same operating condition, same life of oil. So imagine within 1 year, this oil reached from 0.18 acid number to 0.19 acid. This one reached 0.16 to 0.19. Big increase. Then third one, they reduced it. They had the EPT system. 1 month, 2 months was running on this one. They reduced the acid number. The last one, they were using it 6 months with couple of filters. They reduced the acid number to 0.04. So if my question to that site manager is that if you can run this oil with acid number of 0.4, 0.04 on site, why you should wait to have such huge acid numbers in your plant in the same oil with the same turbo machine in the same condition? So it is completely understandable that if the maintenance, right maintenance is applied, it should be applied full time. It should remove the acid all the time. Then look at the particle count. They were having high particles on the first and second turbine. The third and fourth, they improved a lot. MPC, varnish potential 28 to 32 increased. The first, second was 22 to 32 in 1 year. The third was stabilized. They removed a little bit, but 1 month they just filtered it. The last one they removed a lot. The 6 month they could improve a lot. So the point is that on this case they were not doing ruler because Shell was doing the oil analysis for them, and no ruler was not part of the package. Then RPBOT results were there. You look at the drop in the first and second, but the third and the fourth they were quite like stabilized. But the last one, even the MPC was removed, acid was removed, RPVT was removed, was dropping still. Because we don't know the ruler. If the ruler is like zero, like 10%, and you don't have any soldiers, any antioxidant, anything left, then your acid generation is high, your RPVT loss is high. Even you are removing the acid and varnish by a proper system, you will have a still drop of RPVT happening because of high amount of degradation products being available. Yesterday, I was having a meeting with ADNOC in Abu Dhabi. The maintenance engineer asked me a good question. Does your resin-based filtration life increases when the antioxidant is higher? It's completely correct because the antioxidants, they are protecting the base oil as well as making the acid and the varnish less harmful. So once you have the resin-based filtration removing all the time the degradation products, when you have higher amount of antioxidant remaining in the oil, when you start this job, you will be consuming less additives, and additives are also supporting your resin-based filtration. So let's go for the practical part of today. I appreciate you have put your weekend for me. I will try to be fast and delivering all the knowledge I collected in the last, let's say, last time or 10, 15 years I am in this industry now. So oil breakdown happens, the bearing, the normal failures of turbine oil breakdown, we see the bearing deposits sometimes are noted, vibration with sawtooth pattern, some fluctuations, coming and going vibrations, increasing, decreasing, increasing, decreasing. Because you remember, varnish has two phases, soluble and insoluble. It's phase shifter. It comes out of oil, it goes back to the oil based on pressure changes, temperature changes, varnish and solvency of the oil changes. So when you see temperatures and vibrations increasing, decreasing, increasing, decreasing, then it is a sign of varnish formation on the bearing pads. And then obviously oil analysis results are showing high varnish potential, high acid numbers, low RPBOT values, and so on. Then you see the tanks. Tanks are possible to inspect. So you see the stains, you see this varnish on the tanks, and then you see on the control valve components and then servo valve spools. These are clear signs of turbine oil failure. And these are my own photos. I have been inside this Siemens turbine. The manager was telling me every 6 years, 7 years, we change the oil. We never have any problem. This guy, I was telling him that you have a problem, but you have never faced it. He showed me I showed him the photos. He said, no, no, this is a normal color of oil. And later he had a failure on his side. He had already varnish removal units. When the GE Frame 9 bearing replacement comes, and then he sent me these photos, this varnish layer caused the wear issue and bearing failure. When varnish becomes accumulated and accumulated, it becomes bigger than the clearance of the component, then the rotor moves and touches the pads, and then the problem started. He lost around 4 days of unplanned shutdown. He calculated in front of me, he lost around $500,000 production loss to his company due to this 4 days loss. So we are not really talking about filtration cost anymore. This is a huge cost, and also now, this plant was generating power for an oil and gas facility. Then the cost was really huge. It happens, let's say, every 10 years. People are not really focusing on long term. They would say that I'm not there in the plant that the problem comes. Why I need to bother? So this case proved to me that what I was predicting a couple of years back, it came to him. Some more examples of I have been focused a lot on varied forms on the journal bearings, on the inlets, on the wherever the pressure is changing, pressure changes locations, flow changes locations, and then the temperature changes causes varnish to come out. But there will be a time that the oil is completely saturated, higher MPC values, that the varnish will be formed on any surfaces. But the question that the where it forms first, it's a matter of pressure, flow, and temperature changes where it comes out first. MPC around 10, your oil is saturated. It's a matter of time that when the first location depositing happens. This is an SGT 800, the most modern turbine from Siemens. This caused around 3 days shutdown of bearing replacement of $250,000 cost on plant shutdown due to bearing deposits. 3 years after startup of these turbines, was it still in the warranty period, and it caused big problems. Same turbine, gears having varnishing issues as well. Gears and rolling element bearings, they have faster problems. The temperature goes high, vibration goes high. You can have gear tip failures due to varnishing as well. And then on the hydraulic systems of the steam turbine electro-hydraulic control systems, you have these tight clearances in the servo valves. So they will have problems. You have turbine startup issues coming due to varnish, and then cooler performance issues. They are derating turbines to have a cooler oil and to be able to generate power because of varnish incidents. And then this is coming from my colleague. I have a colleague in Canada called Quinton. He was working with Ingersoll Rand many years. He worked with GE and others. So we were discussing that what are uncommon issues or failure modes with the turbine oils. So he sent me some data on the cooler efficiency issues. I wanted to see that how the cooler efficiency is dropping. And then he had some problems with the high-speed bearings, having more problems than the other bearings. And then on the wet seals, he has sent me a lot of failures, and then control system issues. This is one of those cases that my boss was having an ETD. Yeah, the cooler, brother, cooler is the first area because cold oil keeps less varnish inside. Cooler is the first. I will have a photo for you. Cooler is the first location I'm noticing varnishing problem. But cooler efficiency drops. It's not causing mechanical problems, so nobody cares, to be honest. And then this is an emergency trip device of the steam turbine. It's a very critical component, and then varnishing causes problems. And then they use these rubber mallets in US just to make it work because of the varnish can doesn't let the spool to move easily. So to strike the valve and to make it work, this has been because they didn't really feel that the varnishing is causing this problem. And then need to open the cooler to see the we need to remove the inlet and outlet piping, remove the cooler tube plugs, remove the vent plugs to be able to clean all of the varnish. And then he sent me these turbulators photos of when we have varnishing on the cooler, which is the main cause of the oil chemistry not managed and causing these chemistry issues. Myself, I was focused more on the bearing side. As I he was working with turbo machines as a maintenance manager, so he gave me all of these photos. So we need to really define the varnish that it's not only oil insoluble, as we said, it's a soluble product and it is inside the oil. Oxidation happens all the time. Free radical is formed, and then oxidation is there. Again, the alcohols, esters, and acids are all byproducts of oxidation, and all over the time varnish is being generated. It's a matter of when it is going to become out and to become a problem. All turbine oils, they generate varnish. Some of them very good additive package, very good base oil. They make it later. In the later stage, they will be saturated later. But finally, this is going to come. And then we have tested all the major turbine oils in the planet in our lab, and then some of them they go very fast, MPC very high, some of them later stage. It's a matter of base oil and additive package formulation and which one, which oil, without any maintenance, I'm talking, without filtration, which oil makes varnish faster. But we have tested most of them. We know which one is behaving, how it is behaving. Our products need to remove the varnish from all these formulations. So I just want to go to the maintenance side. What are the different technologies of, in my trainings, because I don't see 40 of you and it's a free training weekend. Let us show each other face and everybody's wake up. This is the most important slide of today for me. Can you show yourself? Just say hello, salam alaikum, then I share the slides again. Oh, Ali is waking. Oh, Ghulam is Mr. Ghulam. Thank you, thank you. Aybar.
Assalamu alaikum.
Assalamu alaikum. Let's see. Afruz came also. Very good. Let's see second page. Let me share with you yourself also. You don't see it maybe. Can I show with everyone this one? This is good page now. Oh, Francis is there in Saudi. Very good. Our partner. We have Muhammad Shiraz, Amir, very nice. Akhil is there. Oh, assalamu alaikum. Akhil Shiva is there. Sayyid. Oh, Clinton, assalamu alaikum. Very good. Paper plant. You have power plant in the paper? Brother, you need to unmute. Very good, very good to see you. Last page, I see Mohsen Farooq. Alhamdulillah. Sarahat is there. Everybody waking up. Alhamdulillah. I waked up everybody. Very good, very good. Sorry, making a joke with you. I needed to make sure you are there. I make this joke. They're doing these online trainings only. So, 20 years ago in EPT, there was a guy, I don't name him. He's let's say, one of our main competitors. He was working in EPT 25 years ago. And he gave the idea of if the oil is failing due to two matters. Antioxidant is going low, and then solvency is a problem. Oil is becoming saturated from varnish, and then let us add something to the oil to increase its capacity to keep more varnish. He gave this idea when he was in EPT. So some chemical was added, which increase the holding capacity of varnish inside the oil. And then some additives were added also. Antioxidant additives were added. So It failed because those additives were added to the oil which was having also varnish. Then they will react immediately. And those chemicals, they make their own varnish. It was very good in short term. Why? When you add this chemical, it increases the solvency polarity of the oil, and then the oil cleans the surfaces, puts the varnish back to the oil. The varnish is not disappearing. Varnish is going back to the oil. And then the surfaces are clean, so while vibration goes low, everything is clean. So now you can drain and maybe do flushing, proper flushing, and then put back the new oil. So this is a very good idea, such kind of chemicals, maybe just before a shutdown. But these guys, they started to misuse the lack of knowledge in the industry to go for permanent use of these chemicals. I can say 80% of the turbines in Qatar, they have these chemicals inside. So what's the problem? Like imagine Shell, Total, Mobil, they knew that this chemical, if it is needed, they would have been formulated it from day one. This product is the aftermarket chemical, they call it, and it has its own varnish. It increases the acid number, and it's not needed in the oil. It is something added later on. Then the problem of this chemical is that when you add it to the oil, MPC test is showing zero all the time. Means that okay, there was varnish in the system, it was dissolved back to the oil. Now this mixture of oil plus this chemical is keeping this varnish inside. So MPC test, 1 day heating, 3 days waiting, a non-polar solvent added is not crashing out the varnish which is inside, is not able to show the saturation level of this chemical added. We are doing a lot of R&D on these chemicals. Now Chevron is offering, others of Shell, I really like it that they are not really globally offering it because they know that this is not the right solution. So we have it with ExxonMobil and Chevron, Americans. Then you have it with filtration companies, some of them. And then this is just a short-term solution for a very dirty system to have a very quick fix, is not for long-term use. These guys, they make a Frankenstein oil. They add their own chemical to these oils and they just make it short-term fixed, but this is not the right way. Each of these drum of this oil is like around $5,000. So imagine for a 20,000 liter oil tank. So they consider, they recommend 10% to be added. So let's say 2,000 liter, 5 drum. Each drum is $5,000, $25,000 of chemical to be added. And then short term is showing everything is good, but the long term. One call came to me in Qatar that I was telling them 4 years ago, don't do it. Then it came that they added the last shot of chemical, and then immediately 2 or 3 days after it, bearing temperature went to 90, turbo compressor I'm talking, from 90 to 105, and then immediately all the varnish came out and caused problems. So this is not a really a permanent solution. It's a short-term solution before a shutdown. Second solution, which the name of Europa Filter came, the name of other companies they came. They make many years cellulose-based filters. Cellulose, like tissue paper, it has a very small pores. When you make it dense, when you make it compact, it can capture solid very well. And it's a very good solid removal technique. For removing solid is very good. It's little bit polar. They were writing it that it removes the soluble varnish, but once we have focused too much, they are not really claiming for it anymore. Anything soluble, it will pass through the paper element, cellulose media. It cannot capture anything molecular or soluble inside the oil. The reason they put on these systems cooler, they cool down the oil to be able to force out varnish out from the oil. So they force out part of the varnish out from